The first light of the universe, we're looking at something far more immediate and far stranger. A visitor from deep space, moving through our solar system right now, carrying questions no one quite knows how to answer. It's called 3I Atlas, and if Harvard's rating is anything to go by, it might be something made, not born. 6 out of 10. That's the score Harvard astronomer Avi Loeb gave it on his artificiality scale. 6 out of 10 for being alien technology. Not 1, not 10, 6. The number that lives halfway between disbelief and possibility. It's the cosmic equivalent of a raised eyebrow. Imagine standing outside, late at night, while Mars glows faintly in the sky. Somewhere near it, invisible to your eye but blazing in telescopes, 3I Atlas is passing through 33 billion tons of something no one has ever seen before. It's moving faster than anything built by human hands. It has no tail, though it vents material into space like a comet, and its light doesn't trail behind it. It points forward, as if pulled rather than pushed. Even its chemistry misbehaves. Nickel without iron, a violation of the universe's usual recipe. Picture that, a 5-kilometer wide object slicing silently through the dark, perfectly aligned with the plane of our solar system, an alignment that should happen only 2 times in 1,000 by chance. The numbers don't add up, the physics doesn't behave, and yet there it is, drifting like a message written in a language we've only just begun to notice. Maybe you're listening with the lights low, the day winding down. Funny, isn't it? Somewhere across millions of miles, a rock that shouldn't exist is being photographed, while you and I share this same quiet moment. If you'd like, leave a comment. Tell me where in the world you are and what time it is there. So, dim the lights. Maybe let the fan hum in the background. Because tonight's question isn't just about astronomy. It's about thresholds, the line between nature and design, between the familiar and the unfathomable. And to understand what Harvard means by a 6 out of 10, we'll have to start at the beginning, with the strange, shimmering trail of evidence that brought us here. It began as a blip in the data, faint, fast, and moving too straight. At first, astronomers assumed it was just another comet. But comets don't behave like this. They spin, they shed, they fade. The 3I Atlas didn't. It glowed from the wrong side, as if sunlight was bouncing off something smooth, something deliberate. Let's linger on that image for a moment. A quiet telescope dome under a pre-dawn sky, computers humming softly, and one astronomer rubbing sleep from their eyes as a dot on a screen refuses to do what dots are supposed to do. You know that feeling when a software update appears out of nowhere and your computer insists it's optimizing experience? That's how the universe sometimes behaves. Unannounced, mildly inconvenient, and faintly judgmental. When you first hear about 3I Atlas, it doesn't sound especially cinematic. It's not crashing toward Earth. It's not glowing green. It's not even large enough to impress a blockbuster producer. Yet what makes it extraordinary isn't its drama, but its refusal to conform. You've seen comets before, icy travelers that bloom tails when sunlight warms them, leaving luminous feathers across the dark. 3I Atlas should have been one of those, but instead, it glowed forward. Light poured ahead of its motion like headlights on a car, as if it wanted to see where it was going rather than what it left behind. You imagine standing outside on a still night, the air cool and metallic, a breeze brushing across the skin of the planet. Somewhere up there, beyond Mars, a mountain of metal and ice races silently through the void. It's older than every city on Earth combined, and yet tonight, it's on the front page of your favorite science feed. A headline written in photon and probability. The people studying it sip bad coffee in rooms lit by the blue of monitors. You could almost feel their mixture of exhaustion and awe, that quiet awareness that something from another star system just brushed our doorstep. Astronomers have a habit of naming things with poetry disguised as math. The 3I means it's the third interstellar object ever found, passing through our solar system, the third visitor from elsewhere. Atlas is the survey telescope that spotted it, named after a titan condemned to hold up the heavens, which feels like cosmic irony. You picture this ancient titan shrugging slightly and saying, "Another rock from the neighbors? Sure. Stack it on top." From the start, the numbers whispered rebellion. Its velocity, a clean, sharp 137,000 miles per hour, told scientists it wasn't bound by the Sunday. It would swoop in, glance off gravity's shoulder, and leave forever. Its path was perfectly aligned with the solar system's plane, an almost impossible trajectory. The odds of that alignment happening naturally hover around 0.2%, roughly the same chance as pulling a fully charged phone cable from a drawer on the first try. Then came the mass calculations. Observers measured the dust it spewed into space, roughly 150 kilograms every second, and realized the object wasn't budging. Even under that steady thrust, it showed no acceleration. To behave that calmly, under that much outgassing, it had to weigh at least 33 billion tons. 33 billion. That's heavier than Mount Everest, heavier than the collective anxiety of everyone who's ever tried to parallel park while being watched. And that's when Harvard's Avi Loeb quietly wrote 6/10 next to its name, a 6 on his artificiality scale. Not proof, not even confidence, just a nudge that says, don't dismiss this one yet. You can almost hear the nervous laughter ripple across research teams, the kind that says, we're joking, unless we're not. You lean back and think about how often humanity has stared at odd lights and declared them meaningful. But this time, the evidence isn't an illusion in the sky. It's math, orbit mechanics, spectral analysis. It's the kind of strangeness that doesn't demand belief, only patience. Every reading deepens the mystery. The nickel emission lines without iron, the perfect trajectory, the impossible weight, the forward glow. Each anomaly is like a missing piece from a puzzle that's been chewed by time. You imagine following its path in your mind past Mars, where orbiters are turning their cameras, toward the Sun, where it will swing close before being flung into the dark forever. If you could hitch a ride, you'd see its surface glint like frost on metal, smooth in places, cratered in others. You'd hear nothing, because there is no air for sound. Just your own heartbeat, syncing with the quiet pulse of sunlight, reflecting off something that should not be. What makes the story oddly comforting is how the universe always finds new ways to remind you that you don't know much. You might think you understand comets, gravity, chemistry, then along comes 3I Atlas, politely overturning the table. It's humbling in the best way. You're part of a species that built telescopes precise enough to notice when a rock from another system breaks the rules. So tonight, as data streams back from the orbiters and scientists whisper in Slack channels about spectral curves, you can close your eyes and picture that visitor slipping past Mars, heading inward. You can let your thoughts drift with it, quiet, steady, and a little mischievous, as if the cosmos itself were winking and saying, good luck figuring this one out. Because sometimes, even in a universe ruled by physics, something arrives that feels almost personal. When Avi Loeb proposed his artificiality index, few thought he'd ever use it above a 3. Then came 3I Atlas, and the quiet announcement that it scored a 6. In a field that prizes understatement, a 6 is thunder. It means we can't rule out that this thing was built. Let's take a slow breath and imagine the kind of world where scientists measure alienness on a 10-point scale. Somewhere between microwave lunches and Nobel Prizes, a group of humans decided the cosmos needed a number system for weirdness. You can almost picture it. Fluorescent lights, cold coffee, a chalkboard covered in elegant chaos. At the center of it all, Avi Loeb, part astronomer, part philosopher, part troublemaker, drawing a line down the middle of the universe and labeling it natural on this side, technological on that. You can't really blame him. The universe has a habit of sending things that don't quite fit the manual. First came Oumuamua, that cosmic interloper shaped like a flattened cigar, gliding without the tail of a comet, spinning as if auditioning for a mysterious film. People joked it was alien. Avi didn't joke. He wrote a paper, and for a while, the scientific community looked at him the way people look at someone who brings a harmonica to a silent meditation retreat. Polite, cautious, slightly alarmed. Now, years later, 3I Atlas arrives, and Loeb's scale finally meets its first serious test. 0 means definitely natural, 10 means definitely technological, and everything in between is a polite shrug. A 6, though, is different. A 6 means the evidence for artificiality is compelling enough that ignoring it would be intellectually dishonest. It's the cosmic equivalent of your GPS saying, recalculating. You can picture him explaining it at a conference, calm as a monk in a thunderstorm. The audience sits frozen, their pens hovering over notebooks. He says, the chemistry is off, the dynamics are impossible, and statistically, this shouldn't exist. A few scientists exchange uneasy smiles. Someone coughs into their sleeve. The universe, as usual, refuses to cooperate with professional decorum. You think about how strange it must feel to quantify mystery. Humans love scales. We rate movies, pain, and restaurant service. Now we're rating extraterrestrial possibility. Somewhere between 5 and 7 lies the border between rock and relic. It's almost funny. Our ancestors looked at strange lights and invented gods. We look at strange data and invent spreadsheets. Still, Loeb's reasoning is solid. A 6 isn't a claim of discovery. It's a claim of significance. It means that the pattern of coincidences, the mass, the nickel lines, the forward glow, the improbable trajectory, are too clustered to ignore. It's an invitation to pay attention. Science, at its best, isn't about certainty. It's about listening carefully when the universe whispers nonsense. You might imagine, as you listen to this, that Loeb himself is something of an outlier, a comet in human form. Harvard professors aren't usually known for unsettling dinner parties with talk of alien engineering. Yet here he is, writing papers about the probability of extraterrestrial probes, while the rest of academia politely looks away. It's not that they don't care. It's that science, like polite society, has its topics for the hallway and its topics for the stage. And yet, the thing about data is that it doesn't care about reputation. It just sits there, patient and quiet, until someone brave enough says, wait, that doesn't fit. Loeb's 6 is exactly that moment of pause, the instant before the orchestra realizes the conductor's score might be wrong. Imagine standing under a night sky with this knowledge. Somewhere above, 3I Atlas glides through space, unbothered by the debate it has sparked. Down here, we're arguing about decimals. Up there, a 33 billion ton enigma is humming along, perfectly indifferent to our career risks. It's almost poetic. Humans build entire conferences to discuss what a rock might mean, while the rock itself just keeps going. At its heart, the artificiality index is not a scoreboard, it's a philosophy. It's permission to wonder without apology. A 1 might be an icy pebble, a 10 might be a Dyson sphere. But between those extremes lies the humbling truth that we don't always know which is which. A 6 says, don't jump to conclusions, but don't fall asleep either. You can almost hear Loeb's voice, calm but insistent. If it were purely natural, we would see certain correlations. We don't. Therefore, we ask the question. That's it, not a proclamation, just a question. But in science, questions are contagious. Within days, telescopes across continents adjust their schedules. Graduate students lose sleep. Journal editors prepare for chaos. And you, somewhere between amused and awed, might realize that this is what curiosity looks like at the highest level. It's not shouting. It's the quiet rearranging of assumptions, the gentle tap of a finger on the glass of the unknown. Because maybe a 6 isn't about 3i Atlas at all. Maybe it's about us, our need to measure mystery, to give shape to wonder so it feels less frightening. After all, a scale is just a story we tell ourselves to stay calm while the universe misbehaves. So you close your eyes, imagine the silent object drifting past Mars, and smile at the thought that somewhere, in a Harvard office filled with half-empty coffee cups, someone dared to put a number on awe and called it 6. Weight can be a kind of confession, based on how much material 3i Atlas expels and how little it moves. Scientists calculated its mass. 33 billion tons heavier than any interstellar object we've ever seen. For comparison, that's like throwing Mount Everest between the planets and calling it a pebble. Let's take a quiet breath and think about that number. 33 billion tons. It's the kind of number that doesn't fit comfortably in the human mind. You can picture a mountain maybe, or a skyscraper, or an iceberg, but then you have to multiply that image by thousands until even your imagination starts to sweat. The mind resists. You can't feel that weight. Not really. You can only sense the idea of it. A slow, steady gravity, tugging invisibly on everything nearby. You imagine yourself standing on an open plain at night, a faint wind brushing your face. Somewhere above, 3i Atlas drifts through space, a silent colossus, coasting through sunlight, like a whale, gliding through an invisible ocean. You can't see it, but you can feel the thought of it. Its sheer mass curves the imagination itself. Back in the observatories, scientists tried to make sense of it. Normally, when a comet vents gas and dust into space, it wobbles like a leaky sprinkler. That outflow of material acts like a thruster, pushing it off course in measurable ways. But 3i Atlas didn't flinch. It stayed on track, as if it weighed so much that even the constant venting couldn't move it an inch. That's how the estimate began, not from what it did, but from what it refused to do. If you were in that room as the calculations appeared, you'd hear a kind of stunned silence, the quiet awe of people realizing the universe has outdone itself again. 33 billion tons, someone whispers, as though saying it too loudly might cause it to fall. You can almost smell the coffee going cold on the console, the faint static of computers humming under the weight of data. Numbers on screens flicker, and for a moment, everyone forgets to breathe. To put it in earthly terms, that's about 10 times the mass of all the pyramids of Egypt combined. It's also roughly equivalent to the entire biomass of humanity, multiplied by 1,000. Imagine trying to explain that to an ancient philosopher. Yes, we've found a rock that weighs more than civilization itself. They'd probably nod politely. and then invent another myth. But this isn't myth. The math is annoyingly real. And in astronomy, mass means information. The way something carries its weight tells you how it was made, whether it's porous like ice, solid like metal, or strange like something engineered. The mass of 3I Atlas is so far beyond normal that scientists had to consider possibilities they'd rather not say out loud. You can almost picture the meeting notes. Option: a massive natural fragment of exoplanetary core. Option B: ultra-dense interstellar object of unknown composition. Option C: technological. And there's that long pause, the kind where no one makes eye contact. Because technological is a word that turns coffee rooms into debate stages. Yet, the data wouldn't stop whispering. The outflow rate and trajectory didn't line up with any known comet model. Even if it were mostly rock, it would still be too stable, too smooth, too deliberate. A mass that great should tumble, spin, or at least flinch under solar wind. Instead, it sailed elegant, consistent, eerily calm, like it knew what it was doing. You might laugh softly at the absurdity of it all. Humanity spends decades trying to build rockets that weigh less than a mountain, and the universe casually tosses a 33 billion-ton enigma through our orbit. Somewhere, the cosmos is smirking. Theories began to multiply like over-caffeinated rabbits. Some claimed it was a fragment of a dead star's crust, so compact that it bordered on metallic absurdity. Others thought it might be a planetary shard, the broken piece of a long-destroyed world, ejected at impossible speed. A few, the bold or the reckless, suggested it might be an ancient probe, something built for endurance beyond comprehension, a cosmic buoy, perhaps, or a piece of something once vast. The trouble is, you can't easily verify such things. 3. Atlas doesn't stop for interviews. It doesn't leave calling cards or emission codes. It just moves on slow, steady, indifferent. Even its light curve, the pattern of brightness that reveals rotation, refuses to cooperate. It suggests a shape that's elongated yet symmetrical, reflective but irregular, like polished stone that learned geometry. And as the data piles up, you can feel the question pressing heavier than the mass itself. What kind of event, natural or not, creates something like this? Could a planet's death throw a fragment this dense into interstellar space? Could physics alone sculpt something so precise? Or are we staring at the fossil of intention, the remnant of an idea too large to fade? In the stillness of thought, you realize that's what 3I Atlas really is. A mirror for scale. It reminds you how small everything feels, next to cosmic weight. Your worries, your deadlines, your tiny human gravity all dwarfed by a drifting mountain that doesn't even know you exist. So tonight, as it sails silently past Mars, you can imagine it still carrying its secrets, a 3 billion-ton confession wrapped in motionless grace. It doesn't shout, it doesn't explain, it just glides through the dark, whispering to anyone patient enough to notice. Some things are too heavy for certainty. In physics, light follows the rules. When a comet releases gas, the sun pushes that gas backward, forming a tail. But 3I Atlas glows in front a headlight instead of a trail. No natural process explains it cleanly, though many have tried. Maybe it's rotation, maybe it's reflection, or maybe it's propulsion. Let's ease into this mystery the way light itself might. Softly, curiously, bending around the edges before diving straight in. Picture yourself standing beneath a night sky so clear it hums. The air cool and still, the stars patient and unblinking. Up there, far beyond the reach of any telescope you could hold, a strange object moves against the dark, And instead of trailing light, it leads with it. It's like watching a candle flame walk into the wind. For most scientists, that glow was the first hint that something about 3I Atlas didn't fit. A comet's tail should behave like hair in a breeze, always streaming away from the source of light. But when the first spectral images arrived, they showed a concentrated brightness ahead of the body, not scattered dust, not refracted gas, a focused gleam, as if the sunlight had found something to bounce off. And that's where the questions began, multiplying like photons in a hall of mirrors. You can imagine the lab chatter. Someone says, "Maybe it's rotating unusually fast," while another replies, "Then where's the flicker?" Someone else murmurs, "Could be reflective plating," only to be met with, "From what? A cosmic car wash?" These are serious people. Mind you, professionals with multiple PhDs, yet every new hypothesis somehow sounds like the setup to a joke. That's what 3I Atlas does. It makes geniuses sound like poets who've lost their notes. If you were drifting beside it, just you and the void, you'd see that forward glow like a ghostly halo, faint and constant. It's not bright in the cinematic sense. It doesn't flare or pulse. It's subtle, restrained, as though it's conserving energy. The photons scatter softly off a smooth surface, one that seems to anticipate the sun rather than merely reflect it. You'd reach out a gloved hand, feel nothing but the silence of radiation passing by. Now, let's talk about propulsion. The word itself sends a ripple through astronomy forums like gossip through a small town. Because if that forward light is from propulsion, it means someone or something is steering. The mere whisper of that idea sends caffeine consumption at observatories skyrocketing. A self-propelled interstellar object would be the most significant discovery in modern science, or the most embarrassing misinterpretation, since people thought canals on Mars were aqueducts. Still, the glow persists. Computer models suggest it's too directional to be random sunlight scatter. It's also too steady to be tumbling reflection. Some scientists compared it to ion emission, the kind you see in spacecraft exhaust. Except 3I Atlas doesn't accelerate. It just keeps gliding at the same velocity, like a ship that finished its burn millions of years ago and is now coasting on momentum alone. You lean back in your chair, imagining that, a probe so old its engines have gone cold, still carrying the faint echo of its last push, a relic from a civilization that measured time in millennia instead of minutes. Maybe that's all the glow is: memory, the fossil light of intention, still burning faintly against the cosmic dark. Of course, there are less romantic explanations. Some say it's a trick of geometry, that the object's elongated shape causes sunlight to refract oddly, giving the illusion of a forward shine. Others point to charged dust or magnetic interference. The equations fit, mostly. But deep down, you can tell when scientists start using words like complex interplay or unknown parameter. What they really mean is we don't know yet, but we'd like to keep our jobs. Still, even the skeptics admit it's beautiful. There's something poetic about a light that leads instead of follows, a brightness that refuses to stay in its lane. You picture it as a metaphor, the universe's version of curiosity itself, always leaning forward. In a way, that's what this whole investigation is: light seeking light, knowledge illuminating the unknown. If you stood beneath a telescope dome during one of those observation nights, you'd feel the tension quiet but electric. The room hums with machines and soft murmurs. Screens glow dimly. Somewhere, a researcher stares at the spectral graph, sees that forward peak again, and whispers, "Why?" That's all it takes. One word, spoken softly enough to shake a discipline. And maybe that's the true power of 3I Atlas. It doesn't just bend light, It bends certainty. It forces people who've spent decades studying the predictable dance of comets to look up and admit that maybe, just maybe, there's choreography we haven't seen before. You close your eyes for a moment and imagine the scene in cosmic silence. The object moves steadily onward, its forward light casting a faint shimmer into the void. It's as though it's searching for something just ahead, a destination it will never reach, a question it will never stop asking. And in a small way, that makes it like us, because whether that glow comes from sunlight, physics, or the final exhale of an ancient engine, the result is the same. It pulls us forward. It invites us to follow, to chase the light, to wonder what lies beyond the next curve in the dark. Spectra are the fingerprints of the cosmos. Each element shines in its own color. Yet when scientists looked at 3I Atlas, they saw nickel lines, sharp and bright, and no iron, none at all. It's like finding salt without chlorine, or a melody without rhythm. Chemistry simply doesn't do that. Let's take a slow breath and imagine the scene. A darkened observatory, the kind where even whispers seem too loud. On a monitor, a series of spectral lines flicker fine, precise bands of light, each representing an element's unique identity card. You've got your carbon, your oxygen, your hydrogen, the usual suspects. But then there's nickel, standing out like a lone musician playing beautifully out of tune. And next to it, the note that should be there, iron, is simply missing. Now, in the universe, nickel and iron are inseparable companions. They're forged together in the same cosmic furnaces, supernovae, those vast stellar explosions that scatter the periodic table like confetti. Wherever you find nickel, you find iron. They are cosmic twins, born in the same violent light. To see one without the other is like seeing thunder without lightning, or hearing a laugh with no face attached. It shouldn't happen. Yet there it is, in the spectrum of 3I, Atlas, bright, undeniable, impossible. The first time the data came through, researchers thought their instruments were malfunctioning. Check the calibration, someone muttered. They did, twice. The lines remained. Sharp nickel peaks, iron silence. The universe, once again, had broken its own recipe. Imagine looking up at the night sky, knowing that somewhere out there, an object has rewritten the chemistry of everything you've ever learned. It's not just weird, it's elegant. Because if the universe is a symphony, 3I Atlas is playing a jazz solo in the middle of a classical performance, and everyone's too polite to stop it. There are theories, of course. There are always theories. Some say the object might be made of a rare alloy, the leftover core of a long-dead planet, melted and reforged in a way that separated its elements. Others suggest that the iron might be hidden beneath layers of dust or ice, invisible to our instruments. A few whisper, almost reluctantly, that maybe it's something constructed, a refined material, processed rather than formed. Because if you were designing a probe to survive deep space, you might use nickel, resistant to corrosion, magnetic, durable under extreme temperature, the kind of metal you'd choose if you wanted something to last longer than your civilization. You lean back and think about that. Nickel without iron. It's such a small detail, and yet it opens a canyon of possibility. Science advances not by big explosions, but by small absences, by noticing what isn't there. The missing iron might mean nothing, or it might mean everything. The universe has a way of hiding meaning in its negative spaces. If you were standing beside a spectrograph technician that night, you'd sense their quiet excitement disguised as skepticism. Their hand would hover over the keyboard, their brow furrowed. It could be noise, they'd say. But you can tell they don't believe it, because noise doesn't hold steady through 6 different observations. Noise doesn't sing in the exact same place on the spectrum every time. And here's where the story gets stranger. Nickel isn't just another metal. It's magnetic, reflective, and capable of producing anomalous signals when charged. If 3I Atlas truly is rich in nickel, it might behave differently under sunlight, bending radiation, scattering photons forward. Suddenly, that forward-facing glow from earlier doesn't seem entirely unrelated. One mystery begins to overlap with another, like 2 puzzle pieces clicking together in the dark. You start to wonder, what if these clues aren't separate at all? What if they're part of a single language, one we're only now learning to read? The glow, the weight, the trajectory, the missing iron, all parts of a larger sentence written in the grammar of physics and probability. Still, most scientists resist jumping to conclusions. To them, artificial is a dangerous word. It ends careers faster than black holes eat light. So instead, they talk in softer tones: unusual metallic composition, non-standard emission profile, unexplained spectral deviation. These phrases are the scientific equivalent of whispering ghost without getting kicked out of the seance. But somewhere, someone is already running the numbers differently. Someone in a small lab maybe, with a mug of lukewarm tea, recalculating the spectral ratios and smiling faintly at what they find. Because science, beneath its careful language, is still a human story full of hunches, doubts, and the quiet thrill of maybe being right too early. You picture 3I Atlas out there, gleaming faintly under the Sunday, its nickel surface or whatever it is catching light, scattering it in impossible ways. It doesn't care about our confusion. It doesn't care about Harvard or headlines. It just keeps moving, slow and sure, like a thought too heavy to vanish. And maybe, just maybe, the absence of iron isn't an error. Maybe it's a signature, a deliberate composition, chosen for reasons we can't yet imagine. Like an artist signing their work not with paint, but with silence. So you settle back, listening to the hum of the world around you, and you let that thought linger. Nickel without iron, a fingerprint that doesn't match any known hand, and somewhere in the vast quiet of space, that hand might still be reaching forward. Objects from interstellar space usually arrive at random angles, diving in from above or below the solar system's plane. 3I Atlas came in perfectly flat, threading itself through the planets like a needle. Statistically, that's a 1 in 500 shot, unless someone aimed it. Let's start with that picture, not the numbers, but the motion. You're floating just outside our solar system, a silent observer in the black. Around you stretches the thin, invisible disk, where all the planets orbit the ecliptic plane, a cosmic sheet of glass where everything spins in neat geometry. Most interstellar visitors crash through this plane like tourists who missed the map. But 3I Atlas, it doesn't crash. It glides, perfectly level, perfectly aligned, like a marble rolling along an invisible line drawn between worlds. It's a quiet kind of perfection, the sort that makes scientists nervous, because the universe isn't known for precision. It's messy, noisy, full of cosmic dust and drunken trajectories. So when something moves exactly right, the first instinct isn't awe, it's suspicion. You imagine the observatories on that day, screens glowing with orbital plots, the curves of planetary paths arcing across monitors like golden rings. Then, a new line appears, smooth, flat, unflinching. It's right on the ecliptic. Someone murmurs, leaning closer. Dead center. There's a pause, the sound of a pencil tapping against a desk, The hush of 20 brilliant minds trying to figure out whether the universe just made a perfect shot or whether something else did. To grasp how strange this is, you have to understand just how tilted everything normally is. Interstellar debris, asteroids, comets, even rogue planets, comes from everywhere. They're flung outward by distant suns, spinning like dice across the galaxy. The odds that one of them would just happen to enter our system at exactly the same angle as our own planetary disk are slim enough to make mathematicians squint. About 1 in 500, give or take. That's lottery odds. But then again, maybe the universe does buy a ticket once in a while. You think about that. A 1 in 500 chance. Not impossible, just deeply inconvenient for skeptics. The kind of probability that keeps scientists awake at night, not because it proves anything, but because it refuses to close the case. If it came in from above or below, no one would have batted an eye. But flatness implies intention, or at least familiarity. It's as if 3i Atlas had studied the solar system's layout before deciding to visit. Maybe it's coincidence, maybe it's navigation. Both sound equally absurd when you say them out loud. There's a particular calm that comes from imagining this, the object entering our plane, sliding past the orbits of Neptune and Uranus, coasting silently between worlds that will never know it was there. It doesn't disturb anything. No gravitational wobbles, no collisions, no mess. Just a silent threading through the clockwork of our system. You picture it gliding past Saturn's rings, past Jupiter's storms, past the faint dust of Mars's orbit. A tourist polite enough not to touch anything. And yet, every orbit simulation, every data set, keeps confirming the same thing. 3. Atlas didn't just enter our system by chance. It followed the exact path of least resistance, the gravitational slipstream, the same plane where spacecraft travel when efficiency matters most. It's the cosmic highway used by every probe we've ever sent to other planets because it saves fuel, time, and risk. So the question becomes uncomfortably simple. How did an interstellar object, born light years away, find our freeway on the first try? You can almost hear the laughter in scientific circles, not dismissive, but nervous. Maybe it's just luck, someone says. Or maybe, another replies, the universe has better aim than we do. That's the thing about coincidences. They're harmless until they start piling up. First the weight, then the glow, then the missing iron. Now, perfect alignment. You start to feel the rhythm of it, a pattern forming in the noise. Each anomaly could be natural on its own. Together, they hum like chords in the same song. If you were watching it from afar, you'd feel a kind of reverent unease. 3. Atlas doesn't tumble like debris. It steadies itself. It doesn't cross our system, it joins it. For a moment, aligning its path with ours, as if acknowledging our tiny cosmic stage. The thought is almost intimate, a visitor adjusting its angle just enough to say, I see you. And maybe that's why people keep returning to the idea of aim. It's not that we believe in science fiction. It's that 3i Atlas behaves like something that knows where it's going. The flatness, the precision, the timing, all too neat for randomness, yet too subtle for spectacle. If it were artificial, it's not trying to be noticed, it's trying to belong. But perhaps that's the trick of perspective. We always interpret the universe through ourselves. Maybe 3i Atlas isn't aligned with us. Maybe we're the ones coincidentally aligned with it. A planetary system spinning neatly in the path of something much older, much grander, just passing through. So you sit back, letting the thought settle like dust in sunlight. The object is still moving, still silent, still perfectly flat, a cosmic coin, sliding edge first through eternity. Whether it's an accident or intention doesn't really matter tonight. What matters is that, against impossible odds, it found the narrow line where we live. And in the infinite emptiness of space, that line, that coincidence, feels almost personal. In a cosmic coincidence, or perhaps something else, 3I Atlas will pass close to Mars, so close that orbiters can photograph it in detail. NASA, ESA, and China all reprogrammed their spacecraft for a once-in-a-lifetime shot. The universe rarely gives retakes. Let's begin by picturing that red world, hanging silent in the void. Mars, the quiet neighbor, with a rusted face, always watching from just far enough away to seem lonely. You've seen it in photos: orange dust, faint blue sunsets, valleys deeper than Earth's oceans. But now, something new is coming, not from its sky, not from its surface, but from the deep dark beyond. A visitor, older than the solar system itself, will skim the edge of its orbit like a whispered secret. To call this a coincidence is to call lightning a mild surprise. Space, after all, is too vast for such precision to feel casual. The planets move in their perfect patterns, and yet, for a brief moment, 3I Atlas will thread itself through the same corridor as Mars, a crossing measured in cosmic inches. The odds are staggering. It's as if you tossed a grain of sand from one side of the ocean, and it landed perfectly on another grain waiting on the far shore. Now picture the control rooms on Earth. Screens glow, a pale blue, caffeine perfumes the air, and scientists who've trained their entire lives for predictability are suddenly whispering like gamblers at a roulette table. The NASA engineers check orbital data one more time. The European Space Agency recalibrates its high-resolution cameras. China's Tianwen-1 mission, circling Mars with quiet grace, reorients itself by a few degrees. Not much, just enough to catch a glimpse of something that shouldn't exist. The hum of computers fills the silence. Commands are sent, signals crawl across millions of kilometers, and the spacecraft obey, like obedient children holding up cameras to the heavens. For a few precious hours, every eye, human and machine, will look in the same direction. You can almost hear the tension building, like a held breath stretched across 3 worlds. Mars itself, of course, has no idea what's about to happen. Its dust storms drift lazily across canyons. The robotic explorers, Perseverance, Zhurong, the silent veteran, Curiosity continue their routines, oblivious. But soon, above them, something from another star system will glide past unseen, unheard, unknowable. For a heartbeat, the red planet will play host to a cosmic crossing that not even mythology could have scripted. If you were on the Martian surface, lying in the chill of the night under a salmon-pink sky, you wouldn't see much. 3I Atlas would pass silently, a faint glint in the distance, smaller than a star, but you'd feel it, that strange pull of awareness, that ancient sense that something vast has just brushed by your world. Mars, for all its barrenness, would feel a little less alone. Back on Earth, the data will trickle in slowly, painfully, pixel by pixel. The first image will appear grainy, then sharpen as algorithms stack frames and remove noise. Somewhere, a young scientist will squint at the screen, blink twice, and whisper, "What is that?" The room will fall quiet. You can almost taste the electricity in that silence, the mingling of hope and dread, because this is how discoveries begin, not with shouting, but with breathless stillness. It's worth remembering that the last time we pointed multiple space agencies at one mysterious object, It was Oumuamua, and that story never quite closed. This time, we have better tools, sharper eyes, and an alignment so perfect it borders on eerie. The orbits lined up, as if the solar system itself wanted to help, as if Mars had leaned forward, just a little, to get a better look. The implications are dizzying. A close pass means more than a photograph. It means opportunity. Scientists can measure its composition, track its rotation, watch its behavior under sunlight. They can see whether that strange forward glow brightens near the planet or fades. They can test the theories, rotation, reflection, propulsion, all in one fleeting moment. It's the kind of chance you get once in a civilization. And here's the strange part. Every spacecraft orbiting Mars right now, American, European, Chinese, was built independently for different missions at different times. None of them were designed for this. Yet here they are, converging in unplanned collaboration, as if guided by something larger than planning. Engineers who've never spoken across agencies are suddenly syncing observation windows to the same cosmic clock. You can almost imagine Mars looking up and smiling, finally the center of attention. The object will come and go in hours. The data will take days, maybe weeks, to process. But in that small window, humanity will have its most intimate meeting yet with an interstellar traveler. Not just a passing light, but a measurable, photographable, undeniable thing. Whether it's rock or relic, comet or craft, we will finally see its face. You can feel the poetry of it. A red planet, once thought to harbor life, now standing witness to something that might have come from a place where life actually thrives. The first world we dreamed about colonizing will now serve as our cosmic camera stand, taking a picture of the unknown. As the orbiters turn their lenses, Mars will watch quietly, as it always has, ancient, patient, and just a little closer to mystery. And for one fleeting instant, the lines between science and story will blur. Because sometimes, even the most skeptical astronomer has to admit, the universe has impeccable timing. On October 3rd, 4 orbiters, American, European, and Chinese, will turn their cameras toward the same point in space. For a few hours, they'll all stare at the same mystery. If you were there, it would look like the solar system itself was holding its breath. Let's begin there, at the quiet before the collective gaze. Mars drifts through its orbit as usual, bathed in the red shimmer of dust and dawn. Around it, 4 mechanical watchers machines, built by hands that will never touch Mars' circle, in patient, perfect motion. Their solar panels glint in the sunlight, their lenses poised. For months, they've followed their schedules, sending home data about atmosphere, soil, and storms. But today, every routine goes silent. Today, every eye turns outward, away from the planet, toward a single faint speck in the black. You can almost hear the hum of coordination. NASA's Mars Reconnaissance Orbiter shifting its camera angle, ESA's ExoMars preparing its sensors, Tianwen, one aligning its optics with military precision, even the aging Maven adjusting its instruments for one last spectacular job. These orbiters don't know they're part of history, but the humans behind them do. In command centers across Earth, teams of engineers, scientists, and sleepy graduate students are synchronized across continents and time zones. They speak in acronyms, but what they're really saying is simple. Don't blink. Imagine, for a moment, the choreography involved. Each spacecraft is racing around Mars at thousands of kilometers per hour. They have to pivot, compensate for orbital motion, adjust for signal delay, and hold their aim steady on a moving target hundreds of thousands of kilometers away. It's like trying to photograph a firefly from a roller coaster, while someone else drives the coaster from another planet. And yet, somehow, humanity pulls it off. The countdown begins. The orbiters swing into position, one by one, like dancers taking their mark on a stage the size of a world. On the big screens back home, you can see it, the thin red curve of Mars on one side, the black beyond it, and somewhere in that black, the ghostly trail of 3I Atlas approaching. To the human eye, it's nothing. To the instruments, it's everything. Now picture the solar system from above the clockwork, geometry of planets and moons, each orbit spinning in slow grace. And there, at one small node near Mars, 4 artificial satellites, all looking in the same direction. It's an image of unity so precise, it feels spiritual. 3 nations, 1 mystery, 1 moment. No borders, no politics, no noise, just focus. If you were out there, drifting nearby in silence, you'd see it differently. The 4 orbiters, tiny glints of reflected sunlight, hovering like fireflies above the rust-red world. And beyond them, a faint movement in the dark, the visitor itself, sliding through the void. It would look so quiet, so ordinary, that you'd never guess the history being written in that stillness. On Earth, signals start streaming in. Data packets bounce between deep space network antennas in California, Madrid, and Canberra. The information arrives at the speed of light, slowed only by distance 14 minutes from Mars to Earth. 14 minutes between action and awareness, between reality and comprehension. The scientists wait, staring at monitors full of static that might, at any second, resolve into something extraordinary. It's funny how human this all is. Across history, every great act of observation, from Galileo's first telescope to Hubble's deep field images, has begun with that same nervous waiting, a trembling hand, a moment of silence, a collective inhale. The only difference now is scale. Instead of 1 person at 1 telescope, it's 4 machines on another planet, working together like the eyes of a single enormous organism, the solar system seeing itself see. Somewhere in that silence, you can imagine the orbiters' cameras beginning their long exposures. Each photon that strikes their sensors has traveled for ages reflected sunlight that left the sun 8 minutes ago, bounced off the object, and crossed millions of kilometers more to reach a waiting lens. Every pixel is a tiny miracle of timing. Somewhere, amid the millions, 1 pixel will hold a clue. The shape of 3I Atlas, the pattern of its light, the truth behind its impossible behavior. For now, no one knows which pixel that will be. The teams wait, servers hum, data fills drives, coffee cools untouched. And far above, Mars and the object continue their cosmic dance, neither aware nor impressed that an entire species is watching. If you step back and look at the geometry of this moment, it's almost poetic. Earth watches Mars. Mars watches 3I Atlas. And beyond that, the rest of the universe watches everything, quietly, endlessly. It's a chain of observation, one consciousness nested inside another, curiosity rippling outward through space. And when the images finally arrive clear or blurry, baffling or brilliant, they'll join a continuum of human awe stretching back thousands of years. From cave paintings of the stars to robotic eyes on alien worlds, the impulse is the same: to look, to understand, to connect. Tonight, the solar system is indeed holding its breath, not because something's about to happen, but because something already is the rarest kind of alignment, not of planets, but of purpose. For a few fragile hours, humanity remembers how to look outward together. Every active comet veers slightly off course as sunlight pushes its outgassing jets, but 3I Atlas moves as if made of lead, perfectly gravitational, utterly unbothered. That means it's either impossibly dense or something's compensating. Both options are uncomfortable. Let's take a slow breath here. Imagine drifting beside this thing, not racing, not chasing, just coasting alongside, in the silence of space. The sun is a distant lamp, spilling pale gold across the hull of the solar system. Every normal comet jitters a little as it moves, as if sneezing gas and light into the void. But not this one. 3I Atlas glides like a dream that refuses to wake up. No twitch, no spin, no hesitation, just obedience to gravity itself, like a monk following a sacred path. To astronomers, that's both beautiful and deeply unsettling. The solar system is messy. It's full of chaos tugs, drags, radiation pressure, 1,000 tiny nudges that add up to constant imperfection. Even asteroids drift under the gentle shove of sunlight, a phenomenon called the Yarkovsky effect. But 3I Atlas, it behaves like it's immune. It's as if the universe has decided that the rules apply to everything except this. You can imagine the first few orbital plots coming in curves and equations drawn across monitors, each point a whisper of motion measured in millionths of a second. That can't be right, someone says. They check the math, rerun the models. The result doesn't change. It's not accelerating, another voice murmurs, quieter this time. In science, quiet is how disbelief sounds. Normally, sunlight exerts a gentle push on comets. It's subtle the way a candle flame might nudge a feather across a table. That push changes their paths ever so slightly, creating those elegant arcs we see in their tails. But when researchers mapped 3I Atlas, they found no deviation. Its orbit followed the pure path of Newton's equations, untouched by radiation pressure or gas release. The sun might as well have been a flashlight in another room. So what does that mean? Well, there are two explanations, and neither of them sits comfortably at the scientific dinner table. The first is density, that 3I Atlas is so massive that sunlight simply can't move it. But that brings us back to the earlier riddle. 33 billion tons, perhaps more. A rock that dense shouldn't hold together under its own weight. It would crack, crumble, or collapse, unless it isn't a rock. The second explanation is harder to say out loud. What if something is compensating? Something internal, balancing the forces that should have knocked it off course? A correction mechanism, an invisible counterthrust, subtle and controlled, the kind of precision that feels designed, the kind that whispers, not shouts. You can almost picture it, deep inside the object, a faint hum, a buried rhythm like the heartbeat of an old machine. Maybe it's not running anymore, just echoing, like the last vibration of a bell. Maybe that's why the forward-facing glow remains, faint but constant, a relic of control systems long dormant, still doing their job out of habit, unaware their creators are gone. Of course, no one wants to say that. The astrophysics community has a special tone of voice reserved for the unthinkable. They call it non-gravitational behavior, which sounds safe, neutral, academic. But when the non disappears, when an object moves exactly as gravity dictates, that's even stranger. Because in space, everything misbehaves a little. Nothing is that precise. If you were sitting in one of those control rooms, watching the orbital data scroll by, you'd see the line of prediction overlap perfectly with the line of observation. It's uncanny, the digital equivalent of watching someone trace your signature stroke for stroke, flaw for flaw. You'd start to feel that familiar mix of awe and unease, the sense that you're witnessing perfection where imperfection should reign. The theories began multiplying again. Maybe it's composition, an ultra-dense metallic core. Maybe it's shape streamlined in a way that reduces solar drag. Maybe, just maybe, it's a coincidence. But the more data they gather, the harder it is to dismiss. The numbers don't blink. Some researchers quietly point out that our spacecraft, behave the same way when their propulsion systems are idle. They follow pure gravity until someone corrects their path. But what if something out there is correcting its own? Slowly, gently, without our noticing. That's the sort of thought that makes you wish you hadn't stayed late at the lab. In truth, 3i Atlas is a kind of mirror. It reflects not just sunlight, but our uncertainty, our need to categorize everything, to explain every motion. We build equations, models, simulations, and still it slips through like water through fingers. It reminds us that science, for all its brilliance, is still a flashlight in a cathedral. You sit back and think about that. The missing acceleration, the stillness of the object, moving only where gravity permits, the absence of the little wobbles that define the natural world. It's the calm of something finished, something complete. You can almost feel it gliding through the dark with quiet dignity, a relic that no longer needs to try. Maybe it's not propulsion, maybe it's not density, maybe it's something simpler, a balance between forces so perfect we can't tell they're there. Like a tightrope walker who's stopped swaying, frozen in equilibrium, or like the moment between inhale and exhale, when the world pauses and the only sound is the soft hum of existence. Whatever it is, it moves with intention, or at least with the illusion of it. And as Mars fades behind it, as the orbiters fall back into routine, 3i Atlas keeps its course silent, steady, indifferent, a visitor that doesn't push back against the universe, because maybe, somehow, it already belongs to it. According to interstellar models, a rock this big should pass through our system once every 10,000 years. We've been watching for less than 10. The odds that we'd spot one now are effectively zero, unless there are more, or unless this one meant to be found. Let's begin with perspective, the kind that makes your pulse slow. 10,000 years. That's longer than every recorded civilization on Earth combined. Longer than language, longer than agriculture, longer than bedtime stories. And yet, in all that time, only now in our brief digital flicker of existence do we look up and see something like 3i Atlas coasting through our tiny corner of the cosmos. The math doesn't care about poetry, but it loves irony. Our telescopes have been scanning the skies for barely a decade. In cosmic terms, that's less than a blink inside a blink. The chance that we'd happen to be watching at the exact moment an object like this passes through? Virtually zero. It's like standing in a vast desert with a cup and catching a single drop of rain, not by luck, but because the rain aimed for you. In scientific papers, they call it observational coincidence, a polite term for something weird just happened. Usually, those coincidences vanish when more data arrives. But this one didn't. The more they looked, the more precise it became, as if the universe wanted to underline it. Imagine yourself sitting in a dark room, eyes half closed, hearing that number 10,000 years echo in your mind. You picture the stretch of time between now and the next one. Empires will rise, languages will fade, continents will shift, the stars themselves will change positions, and somewhere another object might pass through maybe. But for now, there's only this one, the visitor that shouldn't exist, It's funny how easily we accept impossible odds when they flatter us. We believe we're lucky when we find love, win a raffle, or stumble on a parking space in front of the cafe. But when luck gets cosmic, we flinch. We start whispering about design, destiny, simulation. The mind wants order, even when the numbers promise chaos. That's why some scientists have begun to wonder, not publicly, of course, not where grant committees can hear them, whether this is coincidence at all. Maybe 3I Atlas wasn't found by chance. Maybe it's bright enough, aligned enough, unusual enough, because it wanted to be. You imagine that possibility, like a story unfolding in the dark, a messenger wandering the galaxy, programmed or guided or just built to be seen, not broadcasting, not waving, just being there, luminous enough to catch the eye of the first species, clever enough to notice, like a cosmic wink. It's the oldest question in astronomy, whispered at the end of long nights under telescope domes. What if we're not just observers? What if we're participants? What if, right now, the act of looking is part of the event itself? Of course, the official explanations remain comfortingly dull. Statistical anomaly, detection bias, unmodeled debris flow, all reasonable, all responsible. But behind those phrases, you can feel the quiet awe. Scientists are human, after all. They may write equations, but they dream in wonder. And somewhere in that wonder, the line between coincidence and intention blurs. Picture it. 3I Atlas sailing past Mars, its surface glinting faintly under sunlight. No signals, no movement, just presence, undeniable and unexplainable. It doesn't need to communicate. It simply exists in a way that feels deliberate, the kind of silence that doesn't imply absence, but restraint. It reminds you of the stories humans have always told of gods descending, of comets as omens, of stars guiding travelers. Maybe this isn't divine at all. Maybe it's just math and motion. But maybe, just maybe, it's a reminder that the universe is still capable of surprise. You lean back and imagine explaining this to someone 1,000 years from now. We saw something, you'd say. That shouldn't have been there. And they'd nod, half believing, half smiling, because that's what every generation says about its mysteries. The universe never stops giving us puzzles, only deadlines to solve them. Still, the odds whisper something more intimate. Out of billions of years and billions of objects, this one arrived in our brief, watchful moment. It didn't smash into us, didn't miss us entirely. It just passed close enough to be noticed. That's not just improbable, it's poetic. If you could float beside it now, you'd feel that poetry in your bones. The hum of probability stretched to breaking, the quiet gravity of chance pretending to be purpose. Maybe that's all existence ever is, a lottery we've already won by being here to notice it. And as you watch it drift onward, you realize the truth hidden in those impossible odds. Sometimes, the universe rolls the dice, not to prove randomness, but to remind us how rare awareness itself is. Maybe it's coincidence, maybe it's choreography. Either way, it found us in the single human century when we could finally look up and see it. Telescopes capture only the blur, a halo of gas, a hint of structure. The upcoming Mars images may show its true body. Is it a lump of rock, a sphere, a shard, or something geometric, symmetrical in a way nature rarely is? Let's drift there, slowly. Picture the object, as it now exists in the collective imagination, a glowing smear on a telescope image, surrounded by pixels and speculation. It's the astronomical equivalent of a rumor. Everyone's heard of it, but no one's really seen it. And that, perhaps, is what makes 3I Atlas so magnetic. The less it reveals, the more the universe leans in to listen. From Earth, it's little more than a fuzzy ellipse, wrapped in faint light. The coma, that thin veil of gas, obscures whatever lies beneath. Every time astronomers sharpen the image, it resists. No sharp edges, no clear outline, just that glowing ambiguity. But geometry, even hidden, has a way of leaving fingerprints. The way the light curves, the way the halo shifts as it turns. All of it hints at a form that might not be natural. You can imagine the conversations cautious, careful, wrapped in scientific euphemism. The light curve suggests non-random reflectivity, one paper will say, which roughly translates to, it's shiny in a suspiciously regular way. Someone else will note possible angular symmetry, which means it might have corners, and we don't like that. The mind, of course, runs ahead of the data. You start to imagine it, not as a rock or a shard, but as something sculpted. Maybe it's octagonal, or disc-shaped, or faceted like crystal. Maybe it's not smooth at all, but lined with seams, the kind that make engineers squint, not geologists. And as soon as that thought forms, you feel the absurdity of it. Because if nature can carve hexagons into Saturn's pole, maybe she's capable of a little geometry elsewhere. But still, the suspicion lingers. The upcoming Mars flyby will change everything. Those orbiters, now aligned like stage lights, will turn their cameras toward the visitor, trying to capture its naked form. For the first time, sunlight reflected off Martian dust will also touch its surface. For the first time, we might see the thing as it truly is. You picture the raw images arriving back on Earth. At first, nothing but static. Then, the faint curve of light. Then, a clearer edge the moment where blur becomes boundary. A shape begins to emerge, and the room of scientists grows quiet. That's how revelation happens in real life. Not with gasps, but with silence too deep to measure. Every comet we've ever imaged has looked messy, lumpy, scarred, asymmetrical, like the aftermath of a billion-year accident. But what if 3I Atlas breaks that rule? What if the light falls across surfaces too even, too regular, a flat plane, a repeating angle, a reflection that holds rather than scatters? That's when geometry stops being abstract and starts being evidence. Of course, even the most disciplined scientists can't resist metaphor. If it turns out to be geometric, one astronomer told a reporter, then either the universe has a sense of humor, or we're not the only ones making art. It's said as a joke, but no one laughs too loudly, because even humor has its limits in the face of symmetry. You think back to all the times humanity thought it recognized patterns where there were none. Faces on Mars, canals on its plains, alien structures that turned out to be shadows. We're good at finding order in chaos. Too good, maybe. But the difference this time is scale. This isn't a blurry image from one camera on one night. This will be multiple images from multiple orbiters across multiple wavelengths. If the shape holds consistent, that's not imagination. That's geometry insisting on itself. The truth is, shapes tell stories. A jagged rock says violence. A sphere says balance. A shard says collision. But a symmetrical polyhedron, something deliberate that says intent, it says choice. And that's what's so unnerving about this moment in the story. Because shape isn't just appearance, it's identity. To see its form is to glimpse its purpose. Maybe it will turn out to be ordinary, an oddly reflective chunk of nickel and dust. Maybe it will be as uneven as every comet before it. But deep down, you can feel the anticipation that something different is coming. There's a poetic symmetry in that too. Humanity, with its telescopes and probes and insomnia, staring into the cosmic blur, waiting for the moment when the universe decides to sharpen the image. It feels like the pause between breaths, the instant before understanding changes everything. And as you sit in that pause, you realize that's the beauty of mystery. It's not about the answers, but about the shape of the waiting. Every strange object attracts skeptics. Some say it's an icy rock from a disrupted exoplanet. Others claim it's an observational illusion. In science, doubt isn't weakness, it's discipline. But when the anomalies stack too neatly, even the doubters start to sound uneasy. Let's take a quiet walk into the mind of skepticism, that steady, cautious heartbeat of science. Picture a conference hall somewhere in Cambridge or Geneva, rows of serious faces under fluorescent light. The projector hums softly, the air smells faintly of coffee and mild panic, and someone at the front of the room clears their throat before saying, "We're not calling it artificial." That's how these things always begin, not with discovery, but with a disclaimer. The doubters aren't villains here. They're guardians, the immune system of knowledge, trained to attack everything suspicious until only truth survives. You can imagine one of them sharp glasses, tired eyes, maybe a tie that hasn't been washed since grad school, scrolling through slides of 3I Atlas data. The glow, the mass, the missing iron, the perfect trajectory, they frown. Coincidence, they mutter. Coincidences happen, and they do. Coincidences are the universe's way of keeping scientists humble, but this one's a bit too polished, a bit too well behaved. It's like a magician who winks every time they say, "pure chance." Still, the skeptics press on. One paper argues that the forward-facing glow might simply be an unusually reflective coma, a puff of dust shaped by solar winds. Another insists that the nickel-iron discrepancy could be the result of instrumental calibration errors. A third proposes that its perfect ecliptic entry was statistically improbable, but not impossible, a phrase that neatly summarizes most of cosmology. They debate each theory with surgical calm, slicing every anomaly open to see what falls out. But beneath the clinical language, there's something else, that creeping tone of uncertainty that sneaks in when reality starts behaving too well. When each explanation fixes one inconsistency but creates two more, the room starts to feel like a hall of mirrors. If you were sitting in the back row, you'd hear the rhythm of scientific humility. We don't know yet. More data needed. Unlikely, but interesting. It's a melody every researcher knows by heart. But here, the notes sound a little strained, too even, too rehearsed. Doubt is starting to feel like denial in a lab coat. That's the thing about anomalies. One is easy to dismiss. 10 start sounding like choreography. 3I Atlas has a way of stacking the improbable into the inevitable. Perfect mass, perfect orbit, perfect timing, perfect glow. It's as if the universe wanted to test how much coincidence we can swallow before we choke. And yet, the true skeptics never lose their calm. They know that certainty is a trap. Science survives not on answers, but on the tension between belief and restraint. You can imagine them late at night, alone in their offices, screens glowing faint blue, running the equations again, not because they expect a different result, but because they can't quite accept the one they've already found. One astrophysicist, after recalculating for the 5th time, writes in her notebook, "Everything fits," and that's the problem. She doesn't mean it poetically, she means it literally. Nature doesn't do tidy. The cosmos prefers chaos, imperfection, entropy. When the math starts to look elegant, that's when you should get suspicious. Meanwhile, the other side of the room, the dreamers, the maybeists, keeps smiling quietly. If it walks like a probe and glows like propulsion, they begin, and the skeptics groan in unison. But beneath the groans, there's a flicker of curiosity they can't suppress, because every skeptic, deep down, remembers the spark that got them into science in the first place. Not doubt, but wonder. The debates go on. Papers are written. Peer reviewers sharpen their knives. Social media swells with confident misunderstandings. The pattern is familiar. Skepticism becomes controversy. Controversy becomes culture war. And somewhere in between, the data gets lost. 3. Atlas doesn't care. It just keeps moving, indifferent to our theories, perfectly silent. You can almost feel the irony, a universe so vast that it breeds both arrogance and humility in equal measure. The skeptics remind us that truth doesn't owe us satisfaction, that being wrong is part of the process, that every maybe in science sits on a mountain of no, and yet, sometimes the mountain shifts. Sometimes, no turns into not yet. In the quiet moments after the meeting's end, when the screens go dark and the coffee cups are cold, you can picture one of those skeptics standing at a window, looking up at the night sky. They know they'll never admit it publicly, but something about this one feels different, not because it proves anything, but because it refuses to fade into randomness. Doubt isn't weakness, it's the scaffolding of discovery. But when the scaffolding starts to shake, even the builders pause to listen. Somewhere between conviction and curiosity, 3 Atlas glides on the universe's most polite dare, and every skeptic, no matter how disciplined, can't help but glance upward and wonder, just for a second, what if we're wrong this time? Avi Loeb has been here before. Years ago, he said Oumuamua might be artificial. The backlash was swift, the ridicule sharper. Now, with 3 Atlas, the data are louder and the silence heavier. Harvard's 6 isn't proof. It's permission to look again. Let's start where all good academic storms begin. A quiet office, stacks of papers, an exhausted professor staring at the ceiling somewhere in Cambridge, the hum of the radiator, the tick of the clock, and that familiar, dangerous thought creeping back in. What if I was right too early? When Avi Loeb first suggested that Oumuamua, the interstellar visitor of 2017, might be something artificial, not necessarily alien, but engineered, the reaction was biblical. Astronomers rolled their eyes. Journals sharpened their editorial knives. Colleagues coughed politely and said words like provocative and unfounded, which, in academia, are synonyms for please stop. But he didn't stop. He wrote books, gave lectures, endured ridicule, all for daring to ask a question that science wasn't ready for. And now, years later, 3 Atlas has drifted into the conversation like a cosmic callback. The same anomalies, but amplified. The same whispers, but this time, the numbers whisper back. No tumbling, no tail, perfect trajectory, forward glow, strange composition, it's déjà vu written across the stars. You can almost hear the sigh of inevitability echoing through Harvard's observatory halls. When the object's measurements came in, Loeb's artificiality index, a playful but methodical scale he once devised to quantify weirdness, gave it a 6 out of 10. Not a declaration of alien origin, but a nudge toward curiosity. A 6 doesn't mean it's built. It means we can't say it's not. And that's enough to reopen every drawer labeled closed case. Imagine the scene. Harvard's Astrophysics department, a sanctuary of logic and skepticism, now filled with quiet murmurs and too much coffee. Graduate students huddle around data projections. Someone's chewing on a pencil like it's a moral decision. Loeb, calm but determined, points at a graph, glowing on the wall, a clean, impossible line tracing 3I Atlas's path. He says something simple, almost gentle. Let's not make the same mistake twice. In that moment, the room shifts, not because anyone believes him outright, but because belief isn't the point. Permission is. Permission to ask the question again, without apology. Science, at its core, isn't about certainty. It's about patience. It's about waiting for the universe to confirm or contradict your most uncomfortable ideas. And if you look closely, 3I Atlas is doing both at once. It's confirming the patterns Loeb saw years ago and contradicting everything that should make them impossible. You can picture him walking the Harvard yard in autumn, leaves crackling underfoot, students hurrying past, without realizing their professor is quietly rewriting cosmology. He doesn't talk about aliens in the pop culture sense. No flying saucers, no little green people. He talks about technology relics of intelligence, perhaps long dead, scattered like cosmic breadcrumbs across the galaxy. He asks, calmly, why would we assume we're the first? That question lands differently now. The timing feels less coincidental, the evidence less forgiving. The doubters from segment 12, the ones who once snickered, are quieter this time, because even disbelief requires footing, and the ground is shifting. Still, Harvard is Harvard. Tradition weighs heavy there. The portraits on the walls have seen centuries of paradigm shifts, from heliocentrism to relativity. They've also seen the ridicule that comes first, always first. Every revolution begins as heresy. You can almost hear the inner conflict in the faculty lounges. The younger researchers eager to run new models. The older ones warning restraint. We mustn't sensationalize, one says. We mustn't ignore it either, another replies. Between those two mustn'ts lies the frontier of science. Meanwhile, Loeb sits quietly at his desk, typing. His tone is measured, his arguments clear. He doesn't shout. He doesn't need to. The data are doing that now. Harvard 6, that cautious, bureaucratic number, spreads through scientific circles like a low-frequency hum. No one's calling it proof, but no one's laughing either. It's fascinating, isn't it? How one institution's measured curiosity can feel like global permission. The same astronomers who once dismissed the idea now find themselves writing papers titled Reevaluating Anomalous Interstellar Objects. The same conferences that once avoided the word artificial now list it on slides, politely framed in quotation marks. It's not belief spreading, it's possibility. The most radical thing science can do is reopen a door it once closed. If you were there, standing at Loeb's window as evening falls over Cambridge, you'd see the glow of the city reflecting faintly off the Charles River. Somewhere out there, in the same light, a 3 billion-ton enigma drifts past Mars. Two lights, one human, one cosmic sharing, a single idea, that maybe curiosity itself is a kind of signal. Harvard 6 isn't a declaration of faith. It's a quiet nod to humility, the acknowledgement that the universe might be stranger than our comfort allows. And sometimes, all progress needs is that one nod. While social media argues about aliens, the real story is happening in peer-reviewed journals and quiet Slack threads. Astrophysicists double-check equations, recalibrate instruments, and wonder in the privacy of their spreadsheets if they've just met technology older than humanity. Let's pull back from the noise for a moment, from the endless scroll of headlines and hashtags, each one louder than the last. Alien probe confirmed? NASA cover-up? Harvard's wild theory? The world loves drama, especially when the universe seems to be speaking. But beneath all that glittering static, Real science hums quietly, methodically, like a heartbeat you can only hear if you listen close enough. In one corner of the world, a graduate student stares at a simulation running on a laptop that's older than she is. Lines of code crawl across the screen, equations mapping out the sunlight pressure, the orbital drift, the strange stability of 3I Atlas. She sips cold coffee, blinks twice, and mutters, "That can't be right." But the result repeats itself, again and again. Somewhere, in the next lab over, someone else sees the same thing. This is how discovery looks before it's glamorous. Not explosions or announcements, but weary eyes and glowing monitors at 3 a.m. It's Slack channels titled Atlas, Data, Webb, 3 final final, half in English, half in math. It's quiet pings in the night. Check the density numbers again. Still no iron lines? Nickel curve confirmed. Still weird. The scientists don't post memes or argue about alien intentions. They post data, graphs, corrections. They argue about the calibration of instruments, the consistency of spectral readings, and the possibility that an entire discipline might be standing on a decimal error. And yet, with every recalculation, the anomaly persists, heavy, patient, undeniable. Meanwhile, the public conversation spirals in the opposite direction. On one side, true believers claim vindication. On the other, professional skeptics tweet long threads about statistical improbabilities. The truth, the real, meticulous, unclickable truth, lives somewhere in between. It's in the peer reviews, in the late-night Slack threads, in the quiet email from one researcher to another that begins, "Off the record, have you seen this?" You can imagine those private moments of hesitation, a scientist hovering over the send button, wondering if they're about to ignite another storm. They've seen what happened to Loeb, to others before him. The cost of curiosity is measured not in reputation alone, but in peace of mind. Yet the drive to understand is stronger than fear. That's the thing about science at its most honest. It's not about proving anyone right. It's about refusing to look away when the data starts whispering something strange. Even the most cautious astrophysicist feels that whisper. It says, keep checking. Don't dismiss the impossible just because it's inconvenient. Across the Atlantic, at an observatory in Spain, a small team reprocesses the light curve data. The lead analyst, a woman with a background in stellar dynamics, notices that the pattern of reflectivity repeats too cleanly, as if light is hitting flat surfaces, not curved, not random flat. She doesn't publish that line in the abstract. Instead, she saves it in a private note. Possible planar symmetry could indicate artificial structuring. Then she closes the file, exhales, and pretends she didn't just type that. That's how paradigm shifts begin, in the notes people are too nervous to share. If you could peek into the digital corridors of academia right now, you wouldn't find certainty. You'd find whispers, questions, a community trying to decide how to stay rational in the face of something that refuses to behave. 3I Atlas has become a kind of mirror for the scientific method itself, a test of whether skepticism can coexist with imagination, and through it all, there's an almost sacred quiet. No one shouts in a Slack thread. They type slowly, carefully. Words like non-gravitational residuals and spectral deviation fill the chat phrases that sound clinical, but carry the weight of wonder. Behind every sentence is the unspoken thought. What if this really is something? Outside those digital walls, the world shouts over itself. Talk shows host experts who haven't looked through a telescope since grade school. Algorithms amplify certainty, not nuance. But the truth, as always, is quieter. It's a whisper in the noise. The irony is that 3i Atlas doesn't need defenders or debunkers. It doesn't care what we call it. It's still out there, gliding between Mars and the asteroid belt, perfectly indifferent to hashtags. It moves with the patience of a teacher, waiting for a distracted class to finally listen. And maybe that's what's really happening beneath the headlines, not a debate about aliens, but a rediscovery of humility. Because whether it turns out to be natural, artificial, or something in between, the real story is how it made humanity stop scrolling for a second and look up. Science, at its best, is the art of listening to the universe, whisper through the noise. And tonight, the whisper sounds a lot like wonder. If each anomaly, mass, glow, chemistry, trajectory has a small chance of happening naturally, multiply them together. The result is a number so tiny it might as well be zero, which leaves two options: coincidence or design. Let's start slowly with numbers, not wonder. Imagine a whiteboard covered in variables, a forest of Greek letters and question marks. Each anomaly of 3i Atlas has its own probability scribbled beside it. A 1 in 2, 0, 0 chance for the ecliptic alignment. 1 in 5, 0, 0 for the perfect stability. 1 in 1, 0, 0, 0 for the forward-facing glow. 1 in 10,000 for the missing acceleration. And so on. The odds shrink with every calculation, and by the time someone multiplies them all together, the room grows quiet. Because what comes out is a number that looks less like probability and more like an accident of typing 0 something. A number so vanishingly small that the universe itself seems to frown and say, "Really?" Of course, science doesn't deal in absolutes. Probabilities are not judgments, they're reflections of what we don't know. But when improbability piles up like this, even the most cautious mathematician starts to feel the floor tilt. Because at some point, a series of coincidences stops feeling random and starts feeling rehearsed. You can imagine the meeting where someone finally said it out loud. The lights dimmed, a slide flickered onto the projector, and in the silence between graphs and models, a voice calm, almost embarrassed, whispered, "If it's coincidence, it's the most coordinated one we've ever seen." No one laughed. The joke was too accurate. Every anomaly alone is defensible. Heavy mass? Sure. Unusual glow? Could happen. Nickel without iron? Odd, but not impossible. Perfect trajectory? Rare, but not cosmic heresy. But all of them in the same object? That's when the math starts to sound like a confession. Scientists have a word for this moment, not proof, but discomfort. The place where data becomes too consistent for comfort, and nature starts looking suspiciously creative. It's not that they want to jump to conclusions, it's that the universe, normally so chaotic, has begun to act. Tidy. If you were there, watching them run the models, you'd see the ritual of disbelief unfold. Recalculations, reprogramming, late-night sanity checks. One astrophysicist in Japan reportedly rebuilt their entire simulation from scratch just to prove it wrong. It still produced the same numbers. Another team ran a Monte Carlo test, 1,000,000 virtual 3i Atlases born from random physics, and not one of them behaved the way the real one does. Not one. You can almost feel the emotional gravity of that realization settling over the field like dusk. It's not the drama of discovery, but the slow, heavy awareness that something fundamental might be off. Either the universe is pulling an elaborate joke, or we've stumbled across design disguised as chance. And design, in the scientific mind, is a dangerous word. It doesn't have to mean aliens or even intention. It could mean something simpler, that physics, at scales we barely understand, can organize itself into structure, precision, and beauty we haven't yet modeled. But it's still the word no one wants to say too loudly. A few brave researchers try to quantify the improbability to see if the numbers might make the idea less terrifying. One paper attempts a Bayesian analysis, treating every anomaly as an independent event. The conclusion, buried deep in the discussion section, is almost poetic. While coincidence remains possible, the joint probability of these observations under standard cometry models is vanishingly small. Vanishingly small, the most polite way to say almost zero. But science has always lived in the space between almost and maybe. That's where imagination sneaks in. You think about it from a broader view. The cosmos is full of absurd coincidences. The moon perfectly covering the sun during eclipses, Jupiter's orbit protecting Earth from impacts, the tilt of our planet, balancing climate like a fragile dance. Maybe improbability is the universe's way of keeping us interested. Maybe it thrives on unlikely beauty. Or maybe, and here's where the thought curls like smoke, maybe improbability is just our word for intention we don't yet recognize. If you were floating out there beside 3i Atlas right now, you wouldn't be thinking about math. You'd see the glint of sunlight across its surface, steady and calm. You'd feel that eerie perfection, the stillness that defies randomness. In that silence, it wouldn't feel like coincidence at all. It would feel deliberate. Back on Earth, though, the calculations continue. Statisticians debate whether the anomalies are truly independent. Philosophers argue about anthropic bias, and data scientists quietly run yet another simulation, hoping, perhaps even praying, that this one will finally give them a normal result. It doesn't. So, the field does what it always does. In moments like this, it divides. Some call it luck, others pattern. A few, whispering into their half-finished drafts, call it something else entirely. At this stage, proof doesn't matter. What matters is the shape of the odds, how, when multiplied together, they form a number smaller than belief, a number that sits on the boundary between science and story. Because when probability collapses, what's left isn't certainty, it's choice. You can call it coincidence, or you can call it design. The universe won't correct you. It will just keep drifting, silent and smiling, as 3i Atlas sails past Mars, a reminder that sometimes math is just the language of awe. Nickel without iron might mean refinement, as if the material was smelted or filtered. Some have joked that 3i Atlas is made of stainless steel, but even jokes leave residue, because what if it is refined? What if someone engineered this metal centuries before we learned to split atoms? Let's step carefully into that thought, not running, not leaping, just walking slow enough for the imagination to adjust its eyes. Picture a telescope image, that faint streak of light sliding across blackness, ordinary to anyone who doesn't know better. But within that streak lies chemistry that doesn't add up: the absence of iron, the abundance of nickel, like a cosmic fingerprint pressed into the light, telling a story of process rather than accident. In nature, nickel and iron are inseparable. They're born together in stellar furnaces, bonded in molten companionship. They cool side by side in planetary cores, alloyed by violence and gravity. To find one without the other is like finding music without time. It means something interfered, something separated, what the cosmos normally keeps married. That's why the word refinement lingers, even when spoken as a joke. Refinement implies choice. It implies hands, or at least intention, because separating metals on that scale doesn't just happen. You need heat, control, precision. You need industry. And that thought, that whisper of industry in the spectrum of a comet, is enough to keep 1,000 scientists up at night, staring at graphs that suddenly look like hieroglyphs. One researcher compared the nickel abundance to the purity found in certain terrestrial alloys, the kind used in turbine blades or spacecraft hulls. "It's absurd," she said, "but the reflectivity curve looks engineered." Then she laughed, as if to sweep the thought away, but the laughter didn't stick. It echoed instead, because once that idea enters the room, it stays. You can imagine the lab where this revelation first landed. A small office at midnight, the hum of instruments, the smell of solder and dust. Someone scrolls through spectral data, eyes half closed from fatigue. Then that sharp, vertical nickel line, clean and arrogant. They check for iron, expecting the twin signature that should always follow. But there's only silence. Just one song playing where a duet should be. They rerun the analysis. They check the detectors. They swap instruments, even move to another observatory. The result doesn't change. Nickel, pure and unapologetic. No iron. The cosmos repeating itself with eerie consistency, as if to say, yes, you read that right. Now the theories branch like nervous trees. Some say 3I Atlas is the stripped core of a world, shattered by impact, its iron long evaporated, its nickel condensed into a solid mass. Others propose exotic astrophysical conditions, magnetic sorting, chemical fractionation, processes too rare to occur twice. But deep down, everyone knows the unspoken option. What if it isn't nature's leftover? What if it's someone's artifact? You don't have to believe in aliens to feel the unease of that sentence. It's not the aliens that are frightening. It's the implication that metallurgy might not be unique to us. That the ability to shape matter, to refine and construct, might be a universal instinct, one that outlives species, languages, and planets. Think of it. A piece of machinery forged in the furnace of another world, older than our entire civilization, drifting silently through the solar system, not broadcasting, not glowing with intent, just existing, long past the purpose that birthed it. Maybe it was part of something larger, once a hull, a satellite, a probe. Maybe it fell away millions of years ago, condemned to wander until some young species with good telescopes finally noticed. The scientist in you wants to reject it outright. The romantic in you can't help but imagine the possibilities. Maybe its nickel-rich surface isn't just reflective. Maybe it's protective. A shield against radiation. A casing designed to endure eons of travel. A message, not written in symbols, but in durability itself. And if that's true, if this thing was engineered, then it carries a silent kind of genius. Because to survive that long, in that state, requires not only knowledge but humility. The humility to build something meant to last long after you're gone. You can feel the weight of that realization settle over the field. The debates, the laughter, the memes, they all fade under the gravity of the question. What if this isn't just another rock? What if it's a relic, a fragment of a civilization that mastered matter the way we're still fumbling with equations? There's something deeply human about how we react to that thought. Some grow defensive, insisting that randomness can explain anything if you give it enough time. Others grow reverent, as if science has just brushed against myth. But most of us hover somewhere in the middle, caught between disbelief and longing, between skepticism and awe. Because even if it turns out to be natural, even if tomorrow some elegant model explains every anomaly, we'll still remember this feeling. The moment the universe looked back at us through a metal fingerprint and whispered, "You're not the first to wonder how things are made." And in that whisper lies both comfort and discomfort, the dual heartbeat of discovery. Maybe 3i Atlas isn't a machine, but the thought that it could be is enough to remind us that knowledge isn't the opposite of mystery. It's the path that runs straight through it. While the orbiters aim outward, Mars itself plays the backdrop, a silent stage for interstellar drama. The same planet where we once searched for microbes may now host our first glimpse of an alien machine. The irony is almost poetic. Imagine the red planet tonight, a cold, ancient world wrapped in its thin whisper of atmosphere. The wind moves dust across dunes, older than all of human civilization. Olympus Mons, that titanic volcano, casts a shadow longer than the distance between cities. The temperature falls to -80, and the only things alive are our own mechanical offspring, rovers, landers, and orbiters circling like patient ghosts. Now imagine, above that stillness, a visitor from the stars drifting silently through the Martian sky. Not a meteor, not a comet in the usual sense, something heavier, slower, deliberate. Mars doesn't notice, of course. Planets rarely do. But for a few days, our machines and that object share the same celestial neighborhood, human technology, staring up at something it was never designed to understand. It's strange to think that this world, the one we've always treated as humanity's next frontier, could become a witness before it becomes a home. Mars, the planet of curiosity, of science fiction, of hopeful colonization, now stands as a neutral observer in a mystery older than humanity itself. It's a poetic symmetry, our search for life there, intersecting with the possible trace of someone else's long before we arrived. If you were standing near the rim of Gale Crater tonight, in a warm suit, with your breath fogging the inside of your helmet, you might see it, just a faint gleam in the distance, moving against the stars, a slow shimmer that doesn't behave like a comet's tail, but like a reflection. It wouldn't make a sound, but you'd feel the weight of its passage, the way you sometimes feel thunder before you hear it. Down on the surface, Perseverance trundles along, oblivious. Its cameras occasionally point skyward, snapping frames of stars, meteors, and dust. One of those images, still sitting unexamined in a database somewhere, might already contain a streak of light that future scientists will rediscover and reclassify. One day, a graduate student might zoom in and whisper, "That's it, that's 3i Atlas, the first accidental photograph of the impossible." Above, the orbiters hold their vigil. The American MRO adjusts its trajectory. The European ExoMars tweaks its alignment. The Chinese Tianwen-1 steadies its instruments. For the first time in history, humanity's collective eye is not on itself, but on something passing through. Mars is the stage, our machines, the audience, and the play itself is light photons bouncing off a mystery that shouldn't exist. You can almost feel the tension on Earth. Mission control rooms glow with the blue light of data streams. Engineers hold their breath as packets arrive from the orbiters. The first images are mostly static, flecks of cosmic interference. Then, faintly, a pattern begins to emerge, a pinpoint brighter than background noise, a streak that's too slow for debris and too steady for illusion. The data teams whisper to one another, not yet daring to speak the thought forming in their collective mind. Mars doesn't know any of this, of course. It simply spins, indifferent and magnificent. The planet that once hosted rivers and seas now hosts a cosmic audience. It's as though time folded for a moment, giving the red world a second chance to witness life, not crawling from its soil, but crossing above its skies. If this were mythology, you could almost imagine Mars as a sentient god, watching a new kind of war, not one of armies, but of ideas, science against imagination, probability against poetry, and the battlefield isn't made of sand and stone, but of questions no one knows how to answer yet. Somewhere, on a quiet ridge, the shadow of a rover stretches across the dust, cast by sunlight that has also touched 3I Atlas. The same light, bouncing from that object's strange surface, travels 8 more minutes to Earth, where it falls through the dome of an observatory, striking a sensor in a dark room. Across millions of miles, a single beam of light connects all 3 worlds, Mars, Earth, and the mystery between them. That's the part that never makes it into headlines. How connected everything really is. Mars, once a symbol of loneliness, is suddenly part of a conversation, a cosmic triangulation. Our robots are watching from one planet, our telescopes from another, and somewhere in the middle, something unknown glides through both of their stories. Even the skeptics feel the poetry of it. The same world that once disappointed us by showing no signs of life may now help reveal something that makes us question what life even means. The irony isn't lost on anyone. The first solid evidence of something extraordinary might come not from Earth, but from the very planet that taught us disappointment in the first place. And maybe that's fitting. Maybe Mars, long patient and silent, deserved this moment to be the backdrop to history, the quiet witness to something vast and humbling. So tonight, while the orbiters point their cameras and the rovers hum in their lonely routines, the red planet listens without ears, speaks without words, and waits without knowing. A witness to a meeting it can never describe. Science rarely has countdowns, but in labs across Earth, people are waiting for photons, for images, for a reason to believe or to dismiss. The quiet before discovery has a unique sound. Server fans, coffee cups, the occasional nervous laugh. It's the strangest kind of stillness, not silence, exactly, but anticipation stretched thin across a planet. In Cambridge, telescopes hum in their housings, catching the faint light reflected off 3I Atlas as it sweeps past Mars. In Pasadena, engineers monitor downlinks from orbiters with the focus of surgeons. In Beijing, a graduate student hovers over a progress bar on a data server, knowing that a single image might make or break careers. The whole world, it seems, has paused to listen for photons that left the Martian sky minutes ago, now racing toward Earth like whispers through the dark. Every scientific breakthrough has its rhythm, and this one feels like the inhale before revelation. The orbiters have done their work, cameras shuttering, sensors blinking, light bouncing from metal to data, from Mars to memory. Now comes the waiting, the 14-minute signal delay, the transmission lag, the agonizing patience required when the universe doesn't hurry for anyone. In rooms full of monitors and blinking LEDs, humans try to make time move faster. They refill mugs, stretch their shoulders, check the same data lines 3 times. Someone jokes weakly about how this is the first all-nighter the cosmos has ever attended. No one laughs, but the mood softens for a moment. That's how science copes with suspense. And then the room settles again. Fingers hover over keyboards. The hum of the servers becomes almost hypnotic. A printer somewhere chirps to life and immediately regrets it. The clock on the wall moves slower than it did yesterday. There's no way to rush discovery, And everyone knows it, but knowledge doesn't make the waiting easier. You can almost see it, a row of scientists staring at a screen as the first packets arrive. Not images yet, just raw telemetry, a river of numbers that mean nothing until they're translated into pixels. One by one, those numbers become light. One by one, the first dots of the universe's newest secret appear. But not yet. For now, it's all just numbers. Waiting is the most human part of science. Every telescope, every experiment, every mission begins with the same heartbeat of uncertainty. The moment before the curtain lifts is where we prove our patience and our faith, not in miracles, but in math. Because every photon we receive, every byte that lands safely on a server, is proof that distance can't kill curiosity. Across the Atlantic, in a quiet observatory in Spain, a technician leans back and watches the live feed from the Mars orbiters trickle through. She rubs her eyes. The console clock flips to a new hour. Somewhere between exhaustion and wonder, she whispers to herself, "It's all just light. That's all it is." And yet, she knows it isn't. Light isn't just data, it's memory. Each photon that hits a sensor tonight left the sun 8 minutes ago, reflected off something older than the solar system, bounced across a Martian dawn, and now lands softly on a human-built lens. That journey, 8 minutes from the sun, 20 from Mars, billions from wherever 3i Atlas began, collapses into a single moment of recognition. If you could stand in one of these labs right now, you'd feel the weight of that idea pressing gently on everyone present. No one's saying it, but they're all thinking it. What if this is the one? The one image that changes everything. The one photo that doesn't blur into noise. The one revelation that justifies every sleepless night. Of course, not everyone feels it as excitement. For some, it's dread. Because if the images show something geometric, something structured, then the questions won't stop. The press will descend. The skeptics will sharpen their pencils. The funding boards will panic. Discovery is thrilling, but it's rarely kind. Still, they wait. They've earned this moment. The irony is that this quiet, this suspended breath, is the part of science that never makes it into documentaries. The world will remember the announcement, the image, the headline, but no one will remember the hours of humming servers and coffee rings. The truth is born not in the flash of revelation, but in the long, anxious stillness before it. And somewhere above Mars, in the cold, perfect silence, 3i Atlas keeps gliding utterly unaware that an entire planet is holding its breath for it. It doesn't care about the coffee cups, the spreadsheets, or the sleepless nights. It just moves, graceful and indifferent, obeying the physics it may or may not have been built to defy. Then, at last, a console light blinks. A data stream stabilizes. Someone leans forward. The photons have arrived. The waiting is over. Or maybe it's just beginning. This isn't the first time a strange object changed our worldview. In 1996, a Martian meteorite hinted at fossilized bacteria. In 2017, Oumuamua slipped past. Each time, humanity flinched, then looked away. 3i Atlas is the third knock on the same cosmic door. Let's begin with that door, the one we pretend not to hear. The universe has been knocking politely for decades, and we've gotten very good at answering with silence. The first knock came in 1996, when scientists held up a small piece of Mars, the meteorite ALH 84001, and claimed they saw the microscopic fossils of life. Little worm-like shapes, tiny trails in ancient rock. The world gasped. The president went on television. We may not be alone. he said. For a moment, humanity stood on the edge of revelation. And then, almost mercifully, doubt arrived. The patterns were dismissed as geology. The excitement cooled. The door stayed closed. The second knock came 21 years later, from Oumuamua, the first known visitor from interstellar space. A thin, elongated object, tumbling strangely, reflecting sunlight in ways that made no sense. It accelerated without an exhaust, moved too fast to be a comet, too awkward to be an asteroid. For weeks, the headlines pulsed with wonder. Alien probe, solar sail, artifact. But skepticism did what skepticism does. Papers were published, debates ensued, and the consensus softened back into comfort. Probably natural, they said. The door creaked, then shut again. And now, a third sound echoes through the hallways of Astronomy 3i Atlas. The name itself feels procedural, almost bureaucratic, as if trying to hide its own mystery under a label. But behind that modest name is something stranger, cleaner, harder to dismiss. It doesn't tumble. It doesn't accelerate. It doesn't fit. It just glides effortlessly, unnervingly across the sky like a thought that refuses to be forgotten. You can feel the repetition in history, the rhythm of discovery followed by retreat. Each generation finds its anomaly, flirts with the extraordinary, then folds it back into the ordinary before bedtime. Maybe it's a kind of intellectual self-defense. Maybe it's fear, because to admit the pattern is to admit the possibility that the universe isn't a story we're writing, but one that's been going on long before we arrived. In every era, the same scene plays out. The lab lights flicker. The data looks strange. Someone says, "This can't be right." Then comes the recalibration, the skepticism, the press release, and finally, the sigh of relief when the anomaly is reclassified into something familiar. It was just a rock. It was just ice. It was just... But the just gets harder to say each time. The ALH 84001 meteorite forced us to confront the possibility that life had touched two worlds. Oumuamua forced us to confront that something might have touched ours. 3i Atlas, though it asks a heavier question, what if something never left? That's the uncomfortable symmetry tying these events together. Each object arrived as if on cue, roughly once a generation, just long enough for collective memory to fade. Each brought evidence too strange to dismiss, but too fragile to confirm. Each left us staring into a mirror of our own uncertainty. You can picture the young scientists studying these cases, now children, during the Oumuamua debates, not yet born when the Martian meteorite caused headlines. For them, 3i Atlas isn't just another anomaly. It's a legacy, a reminder that the universe keeps offering the same question in slightly different forms, and we keep pretending we haven't heard it before. There's a superstition in astronomy that the cosmos reveals things in threes. 3 alignments, 3 events, 3 chances to listen. The first is coincidence. The second is pattern. The third is message. No one in a peer-reviewed journal would ever write that sentence, of course, but you'll find versions of it scribbled in the margins of lab notebooks, whispered at conferences, shared in quiet corners of data chats. And yet, here we are again standing in the echo chamber of discovery. The meteorite was life that might have been. Oumuamua was a messenger that might have passed. 3i Atlas feels like both life and message, absence and arrival. The third knock, soft but insistent. What makes this moment different isn't the object itself, but how humanity has changed around it. We're more connected now, more transparent, less able to bury mystery under bureaucracy. The images from Mars will spread instantly, the debates will unfold in real time, and the door for once may not close so easily. Still, the echo of history is unmistakable. Every anomaly brings with it the same choice: to step forward or to retreat into explanation. And maybe this time, the courage lies not in finding an answer, but in admitting that the question keeps returning because it never left. Somewhere, in the stillness of space, 3i Atlas keeps moving, indifferent to our repetition, patient in its trajectory. It doesn't knock, it waits. The sound we hear, the echo between meteorite, messenger, and mystery, isn't coming from out there. It's the sound of curiosity, remembering its own voice. And it's a massive if 3i Atlas is artificial. What then? A probe? A derelict? A fragment of something once greater? Or perhaps a message not sent to us, but simply passing by, indifferent to who's watching? It's one of those questions that makes even the bravest scientist hesitate before answering, because intent implies authorship, and authorship means agency. It means someone or something once made a decision. That's the threshold no one wants to cross casually. It's safer to talk about mass, albedo, or reflectivity. Numbers don't argue back. Intent does. Let's imagine, gently, that 3i Atlas is not a rock, but a relic, a constructed object, now lifeless, coasting between stars. What would that mean? It wouldn't have to be a spacecraft in the Hollywood sense, no blinking lights or saucer silhouettes. It could be a fragment, a shard of a civilization's technology, surviving long after the civilization itself vanished. Maybe it was never meant to travel here. Maybe it was debris from a collision, wandering aimlessly through interstellar night, until gravity, by pure chance or quiet design, brought it close enough for us to notice. Intent doesn't always mean purpose. Sometimes it means residue. That thought sits heavily in the minds of the scientists awake tonight, staring at the data from Mars. One part of them hopes for geometry, for proof. Another part prays for chaos, for something comfortably random. Because proof brings consequences. If 3i Atlas is a probe, it means someone once built it, and someone once cared to send it. But the timescales involved make that idea feel almost tragic. It could have been launched before mammals existed on Earth. Its creators might be dust now, their own star gone cold. It might be their Voyager, drifting endlessly, a postcard from a civilization that outlived itself. Or perhaps it was never meant to communicate. Maybe it's more like driftwood, the remnant of an ancient technological sea, a piece of something greater, broken and aimless, yet still beautiful in its precision. We often imagine alien intent as grand, but what if it's just accidental? A scrap of someone else's experiment that found us purely by inertia. And yet, a small, reckless part of humanity can't help but wonder, what if it isn't? What if the timing, the alignment, the improbable trajectory weren't chance? What if the glow that faces forward isn't a reflection, but a signal? Not a beam aimed at us, but a rhythm, a pattern designed to outlast its creators, a way of saying, we were here, even if no one remains to explain why. You can picture the late-night discussions unfolding across continents, Slack threads, video calls, hushed conversations that sound more like philosophy than astrophysics. Someone says, "What if it's a warning?" Another replies, "Or a monument." The oldest voice in the room finally murmurs, "Or nothing at all." That's the beauty and burden of intent. It only exists if you choose to see it. Maybe that's what defines intelligence. In the end, not how we build, but how we interpret. We see faces in clouds, messages in noise, and design in symmetry. It's our default mode, our evolutionary compass. The same curiosity that paints meaning on randomness is what brought us to this point, watching an unblinking light drift past Mars. Still, there's something haunting about the idea of a message that doesn't care if it's received, like a bottle cast into a cosmic ocean, knowing the sender will never hear back. 1,000,000 years later, another shore, another mind uncorks it, reads the ink that's long since faded, and wonders what it was meant to say. Maybe that's us now, holding someone else's lost artifact and mistaking indifference for mystery. In the labs, no one says alien. They say non-natural, non-random, non-trivial. Words designed to keep intent at arm's length. But language only delays reckoning. Because if this thing really was made, then somewhere, intelligence has already happened. Somewhere, creation itself was solved long before us. You can almost hear the unspoken tremor in those quiet control rooms. Not fear of invasion, but of irrelevance. The realization that intelligence might not be rare, but temporary. That we might not be special, just next. And maybe, just maybe, that's why this question matters more than proof. Because intent, even imagined, forces humility. It makes us think not about what 3i Atlas is, but about what we are. Another species staring into the void, hoping it stares back kindly. Somewhere out there, that object keeps gliding. No acceleration, no radio signal, no reply. Maybe it's dead, maybe it's dormant, maybe it was never alive in the first place. But its silence feels deliberate, like the pause between sentences in a conversation we didn't start. And as Earth spins, and the orbiters transmit, and the telescopes keep their vigil, humanity finds itself at the edge of a new kind of listening. The kind where you realize that not all messages are meant to be understood. Some are just meant to be found. Even if we find signs of technology, communication may never follow. The object is moving too fast, leaving forever. Sometimes discovery isn't dialogue. It's eavesdropping on a universe that doesn't know we exist. There's a peculiar ache in realizing that silence might be the truest sound of space. For centuries, we've pointed dishes at the sky, waiting for someone to speak some transmission, some pattern, some polite cosmic hello. But what if the universe doesn't do greetings? What if its messages are all monologues, drifting past civilizations that will never overlap in time? 3. Atlas feels like that, not a visitor, but a voice caught mid-sentence, traveling through an audience that arrived too late. Its trajectory guarantees that it will never return, never slow, never orbit. Whatever story it carries began light years away and will continue long after it leaves our little solar system behind. We just happened to be standing near the window when it passed. In mission control rooms across Earth, scientists monitor radio spectrums, scanning for any hint of signal. The data streams come in static, noise, solar interference, and every so often, a flicker that makes someone's heart skip before resolving into nothing. A glitch, a burst, a cosmic shrug. The silence stretches, not empty, but dense, full of everything we wish it would say. You could call it loneliness, but that's too human a word. It's more like awareness, that dawning, realization that we might not be participants in this cosmic conversation. We might just be the ones listening through the walls, catching echoes from a party that ended eons ago. Imagine standing on the surface of Mars as 3i Atlas sails past. The sky would look almost unchanged, just a dim glimmer against the stars. No beam, no pulse, no sign of recognition. Yet you'd know what it was, an impossible thing, gliding silently through history. You'd feel small, yes, but also strangely honored, because even silence, when it comes from that far away, feels like company. In the labs back on Earth, there's debate over whether silence itself can mean something. Could a lack of signal be deliberate, a sign of restraint rather than indifference? We assume communication must be intentional words, code, data, but maybe the truest intelligence doesn't announce itself. Maybe it simply endures. Consider this. Our own Voyager probes are out there right now, sailing the interstellar dark. Their golden records carry greetings in 55 languages, a child's laugh, a kiss of Bach, and Chuck Berry. But even that message will fade. Radiation will scar the disks. In 1,000,000 years, the records will still exist, but any being that finds them will have no context. They'll hear sounds, not meanings. They'll listen and hear nothing the same kind of silence we're hearing now. Maybe that's the natural endpoint of every civilization's curiosity, to build something that outlasts your voice, then trust that someone, somewhere, might one day listen, or might not. Communication becomes less about contact and more about legacy. So when we stare at 3i Atlas, maybe what we're seeing isn't an invitation, but an inheritance, a relic built not to speak, but to persist, not to connect, but to survive. The difference is subtle, but profound, because in that survival, in its silent, steady movement, lies the proof that something once had reason, skill, and will. And yet, there's something almost comforting in that distance. The object won't turn, it won't respond, it won't blink back at our telescopes. It will keep going, unbothered by the noise of a species desperate for conversation. Perhaps that's the universe's way of reminding us that curiosity doesn't require company. The silence between stars isn't a void. It's a language we haven't learned. Every orbit, every glint, every unspoken moment is a syllable in that grammar of quiet. And right now, 3i Atlas is reciting a sentence too large for our translation. It's funny we used to think loneliness was a flaw of evolution, a side effect of consciousness. But maybe it's the opposite. Maybe loneliness is the antenna through which we hear the universe at all. Without it, we'd never have looked up. In a few weeks, 3i Atlas will fade from view. It will join the vast archive of things that were almost understood. Scientists will file the data, write the papers, move on to new mysteries. But late at night, some of them will think about that silence, the way it lingered, the way it almost seemed to hum, and they'll realize that discovery isn't always about hearing something new. Sometimes, it's about finally learning how to listen to what's already there, the quiet conversation between dust and distance, between light and time, between us and everything else. The silence between stars isn't empty. It's patient, it's vast, and it's still speaking, even if it never says our name. Already, online forums buzz with speculation. Some people cheer for aliens, others warn of panic, but somewhere in that noise is the deeper truth that curiosity and fear are siblings, and both wake when the sky behaves oddly. It always begins this way. The data barely dry, the scientists still refreshing their screens, and already humanity has logged on. Reddit threads appear like mushrooms after rain. Twitter fills with threads titled, "Breaking, Harvard just confirmed contact," complete with pixelated screenshots and emojis that would make Copernicus sigh. Someone on YouTube posts a video titled, 3i Atlas, They've Been Watching Us Since Rome, complete with dramatic music and a thumbnail of Mars glowing suspiciously blue. And somehow, despite all our progress, it feels comfortingly familiar hysteria with Wi-Fi. Meanwhile, In the quiet corners of the internet, something gentler unfolds. Amateur astronomers share telescope data, comparing brightness curves. Science communicators record calm explanations that start with, "Now," before anyone panics. Parents tell their kids that, no, aliens aren't landing, but yes, it's okay to look up and wonder, because even panic, at its core, is a form of awe, just one that forgot how to breathe. The world's reaction becomes a kind of mirror. Politicians call for preparedness. Conspiracy theorists call for truth. News anchors call for commercials. Through it all, the same fragile thread connects everyone, a collective tremor between fascination and dread, because nothing unites humanity faster than the suggestion that we are not alone. You can picture it from orbit, billions of small blue lights flickering across the dark side of Earth, each one a phone, a computer, a mind reaching outward through glass and code to make sense of something vast and silent. It's chaos, yes, but it's also communion. For all our noise, this is what humans do best, turn confusion into conversation. And yet, beneath the hashtags and headlines, something older stirs. Curiosity and fear, the twin engines of discovery and disaster. They've driven every great leap we've ever made, from fire to flight to telescopes staring at things that should not exist. Curiosity asks, what if? Fear whispers, what if not? And between them, progress happens, trembling but unstoppable. You can almost feel that duality in the air tonight. On one side of the world, a child stands on a balcony, trying to spot the faint trace of 3 Iatlas through city light. On the other, a retired engineer polishes his backyard telescope, half convinced it's nothing, half hoping it's everything. In living rooms and observatories alike, people lean toward the sky with the same quiet question written across their faces. Who built that? The irony, of course, is that the object itself, if it could think, would probably find our reaction absurd. It doesn't care about our theories, our debates, or our memes. It just travels, ancient and oblivious, while we project our deepest insecurities onto its nickel surface. It's like an unresponsive therapist made of metal. Still, our reaction matters, because it reveals who we are when the unknown knocks. Not paranoid, not naive, just profoundly human. Some build stories, some build shields, and some build telescopes. But all of us, in our own way, look up. That's what unites us, even in disagreement, the instinct to search. Scientists try to keep their tone measured, but even they can't help the small flicker of wonder in their eyes during interviews. It's premature to draw conclusions, they say, followed by a smile that betrays every word. Governments issue careful statements about monitoring the situation. Religions issue none at all. Artists, on the other hand, go wild new songs, poems, digital art pieces with titles like Echoes from Mars and When the Sky Blinked Back. History, in its patient way, takes notes. It's seen this before the telescope turning on Saturn, the first glimpse of bacteria under a lens, the first radio pulse from deep space. Every time, we react the same way, a cocktail of awe, denial, creativity, and mild existential crisis. It's the price of consciousness to crave answers we may not survive hearing. And yet, it's also our most endearing trait, because when faced with the impossible, we don't freeze. We talk, we argue, we meme, we make meaning out of noise. And in doing so, we remind ourselves that discovery isn't just about the cosmos. It's about our capacity to imagine ourselves within it. Somewhere, A late-night talk show host cracks a joke about interstellar stainless steel. Somewhere else, a philosopher writes that 3I Atlas may be the first mirror we've ever held up to the galaxy, and that what we see reflected isn't aliens, but our own hunger to matter. And maybe that's the real story here. Not whether the object is natural or built, but what our reaction says about us. That we are still capable of wonder, even when afraid. That we can hold terror and beauty in the same trembling hands. Because curiosity and fear aren't opposites. They're the two sides of the same telescope. One looks outward, the other inward. And tonight, both are wide awake. Every anomaly in 3I Atlas could have an explanation: dense composition, unusual angle, coincidental chemistry. But stack enough exceptions, and you stop doing physics. You start writing folklore with equations. Physics is supposed to be our anchor, the grand set of rules that never flinch, no matter how weird the universe gets. But every once in a while, something drifts through that refuses to fit the formula. And 3I Atlas has become that something, a polite but stubborn contradiction, gliding through our neat equations like a paperclip in a magnetic field that shouldn't exist. In conference rooms and online seminars, physicists now speak in the language of unease. They say things like non-standard dynamics or uncharacteristic photometry. Those phrases sound calm, but they're code for we have no idea what's going on. Every dataset adds a new exception. Every model another patch to a theory that's starting to look more like a quilt than a law. Let's start with the basics. Gravity. 3I Atlas obeys it just too well. Its motion through space is almost too perfect, as if its path has been fine-tuned to avoid every gravitational irregularity along the way. Natural bodies wobble, drift, or lose energy through sublimation. This one glides, clean as a simulation. That's fine, someone says. Maybe it's denser than we thought, but denser means heavier, and heavier means more light should scatter off it. It doesn't. That leads to the next exception. Its reflectivity behaves like metal, but its thermal signature behaves like rock. It shines like steel, but stays cold as stone. Maybe, says another voice, it's rotating in just the right way to distribute heat evenly. Maybe. And that's the problem. Maybe has become the unit of measurement for 3I Atlas. In physics, the math is supposed to settle arguments. But lately, the equations feel like desperate compromises, elegant lies told to preserve sanity. When the models disagree with the data usually wins. Yet here, neither side concedes. The laws that govern comets and asteroids work perfectly for everything else in the solar system. But not this. This one refuses to be solved without bending something fundamental. It reminds some of the early days of quantum mechanics, when classical physics broke under the weight of the very small. Theorists back then spoke with the same anxious poetry we hear now. We've reached the edge of our map. Maybe 3I Atlas isn't rewriting the rules, just revealing where they've always been incomplete. Still, scientists try to hold the line. They tweak parameters, adjust equations, and propose natural explanations that grow more elaborate with every draft. It's a fragment of a tidally disrupted exoplanet. It's a cometary nucleus frozen with exotic volatiles. It's an aggregate of metal dust compressed by interstellar radiation pressure. All possible, all unsatisfying. It's like trying to explain a dream by listing the furniture in it. And somewhere in that exhaustion, someone finally says it. If we have to invent a dozen exceptions to keep the physics intact, maybe it's the physics that's wrong. That's the heresy no one wants to print. Not because it's impossible, but because it's impolite. The universe isn't supposed to need exceptions. If you've ever watched a physicist defend their equation, you know it's a form of devotion. These aren't just numbers, they're promises. Promises that the cosmos is consistent, that our logic applies everywhere, that no mystery is permanent. But 3I, Atlas, indifferent and precise, makes those promises feel fragile. Every new measurement whispers the same taunt. What if you're not describing me, just approximating me? It's humbling, almost funny, that something so small on the scale of the universe can make us question the foundation of how we think. One object, 33 billion tons of contradiction, drifting past Mars and daring us to admit that maybe the universe still has tricks left. At a recent symposium, one physicist described it perfectly. We're not breaking the laws of physics, we're just discovering their sense of humor. The audience laughed, the kind of laugh that happens when you realize the joke's on you, because that's what it feels like now, as if the universe is teasing us. Every explanation makes sense in isolation, but together they collapse under their own improbability. Too dense, too reflective, too aligned, too pure. It's not one miracle. It's a chain of coincidences strong enough to pull equations out of orbit. And yet, no one can look away, because this is what physics was born for, not the easy, predictable motions of planets, but the beautiful chaos that reminds us the cosmos still has mysteries sharp enough to cut through certainty. So the work continues. Papers pile up, models multiply. The math stretches thinner with every justification. And somewhere in that fragile balance between curiosity and pride, science stands trembling but alive, holding onto its integrity by the tips of its fingers, whispering, "Don't let go yet," because if 3I Atlas truly breaks, even if every theory both fails and fits, then maybe it isn't breaking physics at all. Maybe it's teaching it humility. When October 3rd arrives, humanity will have a front row seat. Orbiters will click open their shutters. Data streams will pulse down to Earth. And somewhere, in a control room filled with tired eyes, someone will see the first clear image. Whatever it shows, the world will change. It begins quietly, the kind of quiet that hums with anticipation. Screens glow in dim rooms across continents, keyboards whisper, and the hum of machinery fills the gaps between human breaths. In Pasadena, engineers sip black coffee that's gone cold an hour ago. In Darmstadt, someone adjusts their headset and murmurs, "Telemetry lock confirmed." In Beijing, the clock ticks toward dawn. For once, the world's scientists are synchronized not by time zones or treaties, but by wonder. Outside, the night sky remains indifferent. Mars glows faintly red, a pinprick of familiarity in a story too strange for comfort. Around it, 4 orbiters align their cameras toward a single invisible point, the predicted coordinates of 3I Atlas. A rock, perhaps, or not. The unknown, hanging in the silence like a held breath. Inside the control rooms, voices lower as countdowns begin. 10, 9, 8. There's no explosion, no liftoff, no roar. Just a sequence of gentle beeps and blinking lights as machines born of human hands prepare to stare into something older than human history. At 0, the shutters open. For a moment, nothing happens. The data comes slowly, photons stretched thin by distance, converted into ones and zeros crawling through the deep space network. Screens flicker with telemetry. Scientists check focus, calibrate brightness, compare exposure settings. Every step measured, ritualistic, reverent. And then the first image, grainy, distant, a dot against a backdrop of stars. Someone leans closer, squints, adjusts the contrast. The dot sharpens. It isn't a sphere. It isn't a shard. It's something else too smooth to be natural, too symmetrical to be random. "We've got it," someone whispers, but no one cheers. The air feels too fragile for sound. Around the world, other control centers confirm the capture. Data packets fly across oceans, through satellites, into the waiting servers of universities and agencies. The same image, the same impossible shape appearing in labs, separated by language, culture, and hemisphere. Humanity, for the first time, looking at something it cannot yet name. Outside, the rest of the planet carries on. People drive to work. Children eat breakfast. Airplanes take off, unaware that just above their atmosphere, a 33 billion ton question mark is being photographed in exquisite detail. The distance between the ordinary and the extraordinary has never been thinner. In Cambridge, Avi Loeb watches from his office, the faint glow of his monitor reflecting off the window. The image downloads line by line, a slow revelation in grayscale. He doesn't smile. Exactly. He just leans forward, as if afraid to blink. Across the Atlantic, a graduate student in Madrid does the same. So does a technician in Houston. Across time zones and sleep schedules, the moment connects them all, a global heartbeat of disbelief. Then, the analysis begins. The first measurements: angles, reflectivity, structural hints. "It's regular," someone says. Regular is a dangerous word in astronomy. It implies geometry. It implies design. Could be coincidence, another voice says too quickly. But no one sounds convinced. You could almost imagine the scene as a movie. The glow of monitors, the faces lit by numbers, the world unknowingly on the edge of its next great question. But this isn't cinema. There's no soundtrack, no crescendo, just the quiet hum of technology doing what it was built to do. Reveal. Outside, night deepens. On Mars, the orbiters continue their watch, looping around the red planet like sentinels tracing invisible patterns. Each pass brings another sliver of clarity, a contour here, a glint there. The images sharpen. The shape becomes undeniable, too linear, too intentional. The kind of symmetry nature doesn't bother with. No one sleeps. Somewhere, a journalist refreshes her inbox, waiting for leaks. Somewhere else, a politician drafts a speech that starts with, "We are not saying what it is, only what it is not." Religion, for now, stays silent. Art will catch up later. And you, if you were watching from space, hovering above it all, would see a blue planet lit by nervous electricity. Billions of minds turning toward the same idea. The same trembling realization that maybe, for the first time, our instruments have looked not just at the cosmos, but into it. And something stared quietly back. At 3:27 UTC, the clearest image arrives. The data decompresses. The noise filters out. And on every monitor, the same form resolves a curved metallic shape, scarred by time, gleaming faintly against the red haze of Mars. It looks, impossibly, like a shell, not smooth enough to be artifice, not rough enough to be stone, something in between. In one control room, someone exhales, almost a prayer. The world doesn't end, the stars don't blink, the sky doesn't fall, but something subtle shifts a collective exhale, a quiet rewriting of what it means to look up. Because tonight, under the same sky that has always ignored us, humanity has seen something that refuses to fit anywhere but memory. And in that silence shared by a planet, echoed by a distant red one, the story of 3I Atlas truly begins. Even if it turns out to be natural, 3I Atlas has already sent a message that we're still capable of wonder, that in a universe where everything seems known, mystery can still slip through. And maybe that's what Harvard 6 really means, not certainty, but the permission to dream responsibly. By now, the data is archived, the press conferences have calmed, and the object itself has long since passed beyond Mars, slipping back into the anonymous dark. The debates continue in podcasts, classrooms, and late-night chats between scientists who promised themselves they'd stop checking the data just one more time. But beneath all the noise, a quieter realization lingers that maybe the real discovery wasn't 3I Atlas at all. It was us, the species that still pauses, still stares, still lets itself be astonished. In the aftermath, papers pile up, each one more careful than the last. Spectroscopic properties of 3I Atlas, constraints on non-gravitational forces, implications for future surveys, dry titles, cautious wording, endless caveats. But between the lines, if you read slowly enough, you can sense the awe bleeding through. Every graph hums with it. Every conclusion hides a heartbeat. Science, when honest, always leaves room for wonder. It just calls it uncertainty. And maybe that's what the Harvard 6 was always about. Not proof, not belief, but permission. Permission to take the leap between data points and ask, what if? Because imagination, handled carefully, is just another instrument of measurement. Without it, science would have stopped at the candle and never found the stars. It's strange how much meaning we've built around one small line of light, one traveler out of nowhere. We gave it names, arguments, purpose. We projected our fears and hopes onto it, like a movie screen. But maybe that's what humans do best. We find stories in the static, constellations in chaos, patterns in randomness. And if we're lucky, sometimes those stories lead us closer to the truth. Think about it, all this. Over a sliver of reflected sunlight, stretched across millions of kilometers, a dot that could fit inside a thumbnail from here, yet big enough to stretch the limits of human comprehension. It's both absurd and perfect that something so indifferent could reignite the world's sense of possibility. Even now, mathematicians run new models, not to prove anything definitive, but to explore what might be. They tweak the parameters, run simulations, let curiosity guide them beyond the comfort of certainty. The equations have become almost poetic variables, standing in for hope, unknowns turning into metaphors. Every line of code feels like a whisper toward the cosmos. Show us something new again. Meanwhile, the public fascination has settled into mythology. 3I Atlas has joined that strange celestial pantheon, alongside Oumuamua, Voyager, and the pale blue dot reminders that we live in a universe that's vast enough to make humility feel like joy. For every skeptic who insists it was just a rock, there's someone else who still looks up at night and smiles, thinking, but what if it wasn't? And that's the quiet miracle of this whole affair. It made us wonder, without losing our reason. It reminded us that skepticism and imagination aren't enemies, but dance partners, each keeping the other from stumbling into absurdity or apathy. To dream responsibly, as Harvard 6 implied, is to hold curiosity in one hand and caution in the other, and never let either one go slack. If you could watch the planet from above tonight, you'd see it a world of glowing cities, observatories, and telescopes still whispering their questions into the dark. Not because we expect answers, but because asking has become its own kind of faith. 3I Atlas won't reply. It doesn't have to. Its message was in the math, in the impossible alignments, the improbable chemistry, the elegant disobedience of natural law. Every anomaly was a syllable in a cosmic sentence that said, "You haven't seen everything yet." And that might be enough. Because discovery isn't about proving the extraordinary. It's about proving that the ordinary still has room to surprise us. It's the act of looking up, of running the numbers even when they don't make sense, of admitting that the unknown isn't a threat. It's a promise. So maybe, in the end, the story of Three-Eye Atlas isn't about aliens, or physics, or proof. Maybe it's about remembering that even in an age of algorithms and certainties, the universe can still outsmart us with beauty. That wonder is renewable, that mystery is mercy, and that sometimes all the cosmos needs to say is nothing at all, and somehow we'll still hear it.